Hello, guys. I hope you're good. I'm also fine. Anyway, let's quickly continue with our lesson. So today we'll be discussing integration of trigonometric functions. So before we start, I just want to take you through the formulas that we'll be using throughout different questions that we'll be solving or under this activity. So let's start with these ones. Let's just first revise or review these ones of differentiation. So let's take, for example, we have the derivative of sine of f of x with respect to x. Then we know that this becomes cos of f of x multiplied by the derivative of the argument. So for this case, it's just going to be multiplied by f prime of x, although it's not written here, but it's there. And then yeah, so let's take, for example, you have sine of x, then this will become cos of x. But then if it's sine of x squared, then it's going to be 2x multiplied by cos of x squared. Makes sense, right? What I'm trying to say is that we always differentiate the argument as well. You understand? So yeah, that's what I'm trying to say. So now let's quickly discuss integration formulas then. So in integration, we know that in integration, what we are trying to do is that we are trying to go back to what was differentiated for us to get this. For example, here you see, when we differentiate sine, we get cos. So in integration, we're given the answer of something that was differentiated, then we go back to what it was before. So if you're given the integral of cos x, then that means the answer is sine x. Makes sense, right? So yeah, this is how it is. So here it is, we have the integral of cos of f of x multiplied by f prime of x, of course, which becomes sine of f of x. So what you need to make sure in integration is that you must always make sure you have the derivative of your argument. So yeah, the argument is, in this case, it's f of x. So when we derive this argument of f of x, we should get something like f prime of x. So that's what you need to always make sure that you have it next to your trig function before you could integrate and say it's equivalent to whatever that it's equivalent to. So for this case, we have cos of f of x, so we had to make sure that there is f prime of x, and then instead then we conclude that the integral of this whole thing is equivalent to sine of f of x plus c. So let me just explain this nicely using equation then for you to get what I'm trying to say. Of course, I don't have to entertain all of these other formulas. I believe you have them. I just wanted to paste them here so that you can also see that I'm using the formulas that you also have. Yeah. Anyway, let's see. Let's see what we can do to this question here. So here we've got sine inverse of integral of sine of 1 minus x dx. I'm sorry about the inverses. I don't know where my mind was. So yeah, here we've got sine of 1 minus x dx. So what I told you is that we need to make sure that we have the derivative of the argument. So the argument for this case is 1 minus x. So we need to make sure that next to this trig function, we must have the derivative of this argument. All right. So let's rewrite this nicely then. So to rewrite this nicely, we're going to say that minus 1, which is the derivative of this, multiplied by sine of 1 minus x dx. Makes sense, right? Let me write it nice. Why is it bending? Sine of 1 minus x dx. But then we didn't have this minus 1 in our equation, so we only wrote this to satisfy our formula for integration, because it says that next to the trig function there should be the derivative of the argument. So I wrote the negative 1 because of I want to satisfy the formula that I have up there. So I want to make use of that formula. So I can't make use of it if I don't have the derivative of the argument here next to my trig function. Makes sense, right? So, but then when I've written this negative 1, it means that I've changed the equation, because this question initially it didn't have negative 1, right? So that means I should cancel this -1 by putting another -1 outside the integral here, so that this -1 and -1, they can cancel each other. But then I'm only gonna make use of what's inside the integral and then just use this formula. Makes sense, right? Or this formula, basically I'm referring to the second formula. So yeah, when I have the derivative of the argument and this trig function, then I can conclude and ask myself this question: what was then differentiated for me to get a sign or positive sign? What was it? It was negative cos, right? So negative cos was differentiated for me to get positive sign. Don't confuse the thing. Don't confuse the -1 that's outside with what I'm trying to explain here. So the -1 here, it's just here to cancel this -1, and then this -1 together with this trig function as well as with this argument allows me to make use of this formula of integral of f prime of x multiplied by sine f of x dx multiplied by which is equivalent to negative cos of f of x plus c. So after writing everything like this, you then ask yourself, what was differentiated for you to get positive sign? Don't mind this, because this is the derivative of this, okay? So don't mind these negatives and the negatives. You understand how you cook them. I understand. I believe you understand how I've cooked them. Yeah. So what you do from here, you ask yourself, what was then differentiated for you to get positive sign? So it was negative cos that was differentiated for you to get positive sign. So outside this integral, we have this -1 here. So multiplied by, so you ask yourself, what was then differentiated for you to get positive sign? So which is negative cos of 1 minus x, then plus c. Then negative and negative, they multiplied each other to get a positive. So at the end of the day, your answer here will be cos of 1 minus x plus c. Then ta-da! You have your answer then. And then that was it. So don't worry, if you don't get it, you're gonna get it. Just stay there. And then you'll see how I solve different questions, of course. So let me just take you through this other one as well. So now we've got integral of tan to the power negative tan 2 to the power negative x upon 2 to the power x dx. So what we need to do is that we need to make sure we have the derivative of the argument first. Of course, we need to make sure we have the derivative of the argument. So 2 to the power negative x, when we differentiate it, it should be 2 to the power negative x multiplied by -1 multiplied by ln of 2. So we don't have -1 and ln of 2. We need to cook it before we can make use of any any integration formulas there. So let's then rewrite this nicely before that. So let's go. So let's rewrite this nicely. So tan 2 to the power negative x, for us to be able to integrate this, we must have, so let's take these 2 up. So when we take these 2 up, we're gonna have 2 to the power negative x, of course. So when we differentiate 2 to the power negative x, we should have 2 to the power negative x multiplied by the derivative of the angle there, because if it's a cos, it's an exponential function. So it's gonna be -1 multiplied by what? ln of 2, then dx. So when we check our equation, we were only given 2 to the power negative x, which was 2 to the power x. Of course, I just took it up and then it changed then the sign of the exponent. So As for -1 and 2 and ln of the base, they were not there, but then they should be there for us to be able to use the formula for integrating tan. So, but then if we just write them like this, then that means we are changing our equation, because the equation didn't have -1 multiplied by ln of 2. So we should cancel this -1 and ln of 2. Makes sense, right? So to cancel that, we need to just multiply this integral by 1 over, or -1 over ln of 2. So this outside there, I'm going to multiply by negative ln of 2. Makes sense, right? So from here, if I have a trig function alongside with the derivative of the argument, then I can then conclude that the thing that was differentiated for me to get tan was ln of sec, according to the formulas that I attached here. So the thing that was, if I have the derivative of the argument and this trig function of tan, then I can conclude that the thing that was integrated here was ln of sec plus c, because I have the derivative of the argument plus multiplied by this trig function of tan. Then I can conclude that whatever that was differentiated was ln of sec plus c. So that's how we go about with it. So don't leave out this, whatever that's outside there should be attached to the answer there. So -1 over ln of 2 multiplied by whatever that was differentiated to get tan, which is ln of sec 2 to the power -x, and then plus c. Then ta-da, you have your answer. So that's how we assess these things of trig functions, integration of trig functions. That's what I'm trying to say, of course. So yeah, it's easy. I hope you are getting the concept. So anyway, here I have, what do I have here? I've got the integral of 1 over 1 plus cos x. So this is, you need to cram this one. This one you need to cram it. You need to cram this one, of course. So whenever we have a constant divided by a constant plus any trig function, you need to then multiply by 1. And that 1 should be a Pythagorean conjugate, So please cram this shape. In mathematics, you just cram the shape of numbers, not necessarily the equation, but the shape. When you have a constant divided by a constant plus or minus any trig function that you can have, it could be your sine, your cos, or whatever, then you need to then think of multiplying by 1, and that 1 should be a Pythagorean conjugate of what you have there. So for this case, this is going to be the following. So this is going to be the following. We're going to have our 1 up there, divided by 1 plus cos of x multiplied by the Pythagorean conjugate. For this case, is going to be 1 minus cos of x divided by 1 minus cos of x dx. So that's it. And then from there, you are going to what is this? You're going to just multiply the numerator and the numerator. You're going to multiply the numerator and the numerator, and then denominator and the denominator, they're going to multiply each other. So on the numerator there, we will end up getting 1 minus cos of x, and then on our denominator there, we will get 1 minus cos squared of x, and then dx. Then 1 minus cos squared of x is gonna become sine squared of x from the square identities. So this is going to be then equivalent to 1 minus cos of x divided by the sine squared of x. So here I'm gonna write my sine squared of x dx. Then for us to be able to integrate this, we can see that we need to just split and then split. So we are going to make each and every numerator term to have its own denominator. You see, the whole process that I'm going to do here, you need to cram it as a whole, because it's never going to change. Like, the process is going to be the same. You need to just know that, or cram, that after changing this into after you see here, we had 1 minus cos squared, then we changed into sine squared, then after that we split and make each and every numerator term to have its own denominator, meaning that we're gonna have 1 over sine squared minus cos divided by sine squared. So at the end of the day, this is gonna be something like 1 over sine squared of x dx minus the integral of cos x divided by sine squared of x dx. And then from here we can see that 1 over sine squared, we can't integrate it, but then if ever we change this into its reciprocal, which is what, cosec, right? Which is cosec squared. So if we change this into cosec squared, then this is going to be equivalent to cosec squared of x dx minus, and then also this other side. So on this other side, this could be done in 2 ways. One might say they can just use what is this, general power rule. One can say I want to use I can just simplify this and say 1 over sine cos over sine cos. We have 2 sines here, meaning that they splitted this sine squared into 2 sines. So at the end of the day, that will make 1 over sine multiplied by cos over sine, and then that becomes, and then we change it into okay, let me just write here on the side. Now let me just write what I'm trying to say. So this thing could be in 2 ways. One could say that this could be equals to the integral of cos of x multiplied by sine of x to the power -2 dx, or one could say this is the same as this one here is the same as 1 over sine x multiplied by cos of x divided by sine of x dx. So what happened here is that we splitted this sine squared into sine, and then 1 over sine cos over sine, so that we can use we can make use of the reciprocals again here. These two are the same things. They will give you like the same they will give you correct answers for this integral. Okay, so it's up to you what you want to do there. So for this case, let's just use which one? Let's just use the second one, but both of them are correct. To verify that they are correct, I've taught you that you can find the answer for this and answer for this, and then differentiate those answers. You'll see you'll get back to the same thing. So that's how you verify the answers. So anyway, let me just use this for the sake of time. I don't have to verify the answers. That's your job. So yeah, let's just make use of this second one. So 1 over sine x, what is it? It's cosec, right? So that means here I can say we've got the integral of cosec of x multiplied by cos over sine, that's a cot. So we again have cot of x dx, and then that's it. So now our thing, it's more like it's written nicely. So let's see what we can then do to this question. So now we ask ourselves, what was then differentiated for us to get cos x squared? Because the derivative of x is 1 here, so we don't have to worry about the derivative of the argument because it's 1 and 1 which is here. So we ask ourselves, what was differentiated for us to get cos x squared? It is negative cot, right? Because of when we differentiate positive cot, we get negative. So here there is no negative. So meaning that the thing that was differentiated for us to get this positive cosec was negative cot. Negative cot. So this is going to be negative cot of x. And then we move to the following one. So here we ask ourselves, what was then differentiated for us to get positive cosec cot x? Or one can say, okay, one can say if to make things simple, we can just take the negative inside and then we change this sign to positive. Make sense? Yeah, I hope it does. I hope it does. So one could say that what was then differentiated for me to get negative cosec cot? It was positive cosec of x. So yeah, that's it. Because of the derivative of the argument, there is going to be 1, so we don't have to worry about it. So then the answer for this becomes positive cosec of x plus c. Then tada, you have your answer. So yeah, that's just it. So yeah, let's quickly discuss this activity then, and then we'll be fine from there. So here we're required to integrate the following questions under activity 5. So as for number 1, we've got the integral of sine 3x plus cos of 5x dx. So what we're gonna do is to just rewrite this first nicely. So I can split them. Let me just split them and have sine of 3x dx plus the integral of cos of 5x dx. Remember, whenever we're integrating this, we should make sure that we have the integral of the argument. So the argument for this case, we have the derivative of the argument next to the trig function. So now we're integrating this sine of 3x. When we check the argument, it's 3x. So we don't have the derivative of this argument, of course. So we need to make sure that before we could integrate this, we must have the derivative of the argument. So the derivative of 3x is 3, right? So you'll come here and write your 3. But then because of you didn't have this 3, you writing it then means that you are changing the equation. So we don't want to change the equation, but then we wanna make use of this 3. So to make use of it without having to change the equation, we just multiply by 1 over 3 so that the 3 and 3 cancel each other. But then now we don't cancel because we wanna make use of the derivative of the argument with this trig function. And then we come to this case when we do the same thing. The derivative of 5, it's 5. The derivative of 5x is 5. And then we cancel the 5 by putting 1 over 5 there. Then we integrate. So now if we have the derivative of the argument alongside with this trig function, then we can just ask ourselves, what was differentiated for us to get positive sign? What was it? Because it's positive here. What was it? It's negative cos, right? So this is going to be negative cos that was differentiated for us to get this thing of sine. So we can then conclude there this. So we take this 1 over 3 to our answer there. So it's going to be negative. The thing that was differentiated, it's negative cos of 3x. You get it, right? And then we come to this case. If we have the derivative of the argument multiplied by this trig function, we can just ask ourselves, what is it that was differentiated for us to get positive cos? What was it? It was positive sine, right? So we're going to take the 1 over 5 that's outside. So it's going to be 1 over 5 sine of 5x plus c. Then, ta-da! You have your answer. So yeah, that was it. Easy busy, easy busy. Oh, I should have discussed this type up there, but it's fine. Late is better than never. Anyway, in cases like this whereby you have sine squared, you need to then do this. I should have explained this under the examples, but I'm sorry. So yeah, whenever you have the integral of sine squared, cos squared, you need to make use of the half angle identities for you to be able to integrate this. Because even if you can say you want to change this to 1 minus cos squared, then you still have cos squared, so you're still going to have the same problem, which is the squared. So to run away from this cos squared, you then need to make use of the half angle identities. So the half angle identity for sine squared of 3x is equivalent to 1 over 2 multiplied by 1 minus cos of what? Because you know this, you must know all of these things. So sine squared of 3x is going to be equivalent to 1 over 2 into 1 minus cos of 2 times 3x. So that means it's going to be cos of 6x. So that means here we are going to rewrite this into this following thing. So it is going to be equivalent to 1 over 2 into 1 minus cos of 6x, and then the x, and then from there it will be easy for you to integrate this than that. So yeah, this is what we always do. So please cram this thing, because if it's gonna come back again in other questions that we're gonna do, I believe. So please cram this format. Whenever we have sine squared or cos squared, we need to make use of the trig half angle identities. So yeah, that's it. So from here we're gonna split this. This is going to be 1 over 2 multiplied by 1 dx minus 1 over 2 multiplied by the integral of cos of 6x dx. 6x dx. And then yeah, then with the integral of 1, of course, that's simple. Everyone knows it, even me, I know it. Then yeah, that's going to be the integral of 1 dx is just going to be the 1 over 2 that's outside multiplied by the x. So the integral of 1 in short is just x, and then you will come this side. So we have a trig function. We should make sure that we've got the derivative of the argument next to this trig function. So when we derivate 6x, what do we get? We get a 6, right? So that's 6, you write it here. But then you writing this 6 means that you have changed the equation. So you need to make sure you don't change the equation that you are given in the test. So what do you do to cancel this equation to cancel this 6 without really cancelling it? You multiply by 1 over 6. So you multiply by 1 over 6. So here I'm going to multiply by 1 over 6. And then now, if I have the derivative of the argument alongside with this trig function, then I can ask myself, what is it that was differentiated for me to get this positive cos? So it's what? It's positive sine, right? So I'm just going to take whatever constants that I have outside my integral, to my answer. So I'm gonna get 1 minus 1 over 12, which is 2 times 6, right? It's my 12. So then when I've asked myself that the thing that was differentiated for me to get this positive cos was what was positive sine, right? Then the answer for this integral then becomes positive sine of 6x and then plus c. Ta-da! You have your answer. Makes sense, right? Yes, it has to make some sense there. Anyway, let's quickly continue. All right, let me just do this one. Then from there, you stop watching a movie, you start doing the questions as well. I believe after this question, now you will be confident as well. You can even be a tutor after this question, right? That's my belief. Well, we believe in different things, eh? Some other people's beliefs are not make sure. All right, let's continue. So we've got the integral of sec x, which multiplies sec of x plus tan x dx. So what are we going to do to integrate this? Definitely, there is nothing that was ever differentiated for us to get sec x multiplied by this complicated like this. So we need to rewrite this thing in a simple way for us to be able to see what was differentiated. You understand? Because the way it is, no way. I've never seen something like that. So yeah, let's rewrite this in a nice way for us to be able to see what was differentiated. So yeah, it's more like us simplifying, saying that we are simplifying, kinda. So yeah, let's simplify this. So this is going to be sec multiplied by sec, it becomes sec squared of x. And then sec multiplied by tan, it becomes sec of x multiplied by tan of x. Then our dx there. Then it is nice, right? And then from there, we can either decide to split or not. Are we splitting? Let's just split then, because I can hear you saying split. Didn't you say so? All right, sec dx and then plus integral of sec of x multiplied by tan of x dx. So here you can see that we've got sec squared, and we also have got sec x tan x. All right, so we start with this case. The argument there is what? It's x. When we differentiate x, we get a 1 which is there, and then now that means we can just proceed with our integral techniques. So we can ask ourselves, what is it that was differentiated for us to get sec squared? So you take yourself back there, and then you try to think, you think, then when you're done, you will come to a conclusion that the thing that was differentiated for me to get positive sec squared was what? Was tan of x. Then your answer then you come to your answer and say this is tan of x. Then tada. All right, before you tada, you come to this. You tada when you have plus c. Then here we check our argument. So the argument here, it's x and x. So whenever we differentiate x, we get a 1 that is there. So now that means we can proceed with our integral techniques and make use of our trig functions, integration formulas for integrating trig functions. So what you're going to ask yourself here, that what is it that was differentiated for you to get sec x tan x? What is it? It is your sec x. So the thing that was differentiated for you to get positive sec of x tan x was positive sec of x, then plus c. Ta-da! You have your answer. So yeah, that's just it. Okay, movie time, it's over. It's now your time to work on these questions as well. So guys, feel free to pause the video and then start working on these problems as I do them as well, and then You can resume later just after that to check how I've done it as well, or to confirm if we did the same thing. Of course, I mean, I will always do the correct thing, right? So you'll be resuming the video there to check the memo, of course. Yeah, so yeah, feel free to pause this video and work out these problems on your own that side, and then resume later to check the memo. So yeah, let's see. So now we've got our 1 over cos of 2x inside our integral. So we can see that definitely there is nothing that was differentiated to get 1 over cos. So we need to rewrite this nicely before by making use of reciprocals. So we know that 1 over cos is equivalent to what? To what is this? My mind is running. 1 over cos is equivalent to sec, right? So this is going to be sec of 2x. So this is going to be sec of 2x. So this is going to be 1 over cos. I changed it into its reciprocal, which is sec of 2x, and then dx. So from here, before we make use of any integral formulas, we need to make sure that we've got the derivative of the argument. The argument in this case, it's 2x. So when we differentiate 2x, what do we get? We get a 2. So that 2, we write it here. But then you writing the 2, you are changing the equation. So we don't want to change the equation, man. So we cancel that 2 by multiplying by 1 over 2 outside our integral. And then we come back into this. If we have the derivative of the argument and a trig function, we can then make use of those integral formulas, and then we ask ourselves, what is it that was differentiated, I mean, for us to get this positive sec? Then you will make use of the formulas, of course, and then you will come to a conclusion that it was okay. You'll take this 1 over 2 to your answer, and then you say the thing that was differentiated for you to get sec or positive sec was ln of what? Natural log of what? Of sec of that thing, the argument, plus tan of 2x, and then plus c. Ta-da! That's your final answer there. So I hope we got the same thing, guys. So let's quickly check another one because we're running out of time. All right, here's the other question that we have here. Let's quickly see what we can do to it. Let's quickly show it what we are made of. What are we made of? So yeah, now we've got the integral of 1 divided by sine squared. So this is similar to what we were dealing with there. So we need to rewrite this nicely first. So to rewrite this nicely, you need to make use of our reciprocals. So the reciprocal of 1 over sine, what is it? It's cosec, right? So this is going to be cosec squared. So this is going to be CSC squared of EX and then VX. So when you have this, when you have a trig function, you need to make sure that you have the derivative of the argument next to this trig function. So the derivative of EX, it's what? It's going to be just E, right? But then you didn't have the E in your equation, so you need to cancel this E by dividing by multiplying by 1 over E outside there. Then you ask yourself, if I have the derivative of the argument alongside with this trig function, then I can then ask myself that what was it that was differentiated for me to get cosec squared, and for this case positive cosec squared. What is it that was differentiated for me to get positive cosec squared? What is it? It was negative cot, right? So negative cot was differentiated there for you to get positive cos x squared. So then you take whatever that's outside the integral there to your answer. So this is going to be 1 over a so it's going to be negative because of it was negative cot that was differentiated there. So this is going to be negative cot of e x plus c. Then ta-da, you have your answer there. So yeah, that's just it. There's nothing fancy there, nothing fancy. It's just you working with these numbers in a nice way. So let's continue then. Let's quickly see if we can solve something else. Now we've got tan squared so all right, so all right, so now we've got the integral of tan squared of 4x dx. So when we check, of course we need to make sure that there is the derivative of of the argument next to it. So we can just put 1 over 4 and 4 here. Of course it's gonna be good, but then we're gonna get stuck when we ask ourselves, what is it that was differentiated for us to get tan squared of 4x? We'll find that no way, that thing is not there, is not make sure. So you need to then do something to this tan to make sure that we'll end up having something that that we can conclude it was this that was differentiated for us to get that thing. You understand? That's what I'm trying to say. So well, for this case, whenever we have tan squared, we're just gonna make use of our square identities. We know that tan squared is equivalent to sec squared minus 1. So tan squared is equivalent to sec squared minus 1. So that's what we're gonna substitute in there for us to be able to simplify what we have. So yeah, let's just substitute. So let's substitute. So before we do anything, let's just substitute this. So this is going to be, so tan squared itself is equivalent to sec squared of 4x minus 1, and then dx, just like that. So that's what I'm trying to say. So when we have what is this? When we have sec squared minus 1, then it's gonna be easier for us to integrate because of we know that there was something that was differentiated for us to get sec squared, and then the integral of 1 is just simple as a b c. So let's rewrite this nicely then. Let's just split them and write them nicely. So this is going to be sec squared of 4x dx minus the integral of 1 dx. So for this case, whenever we have a trig function, we have to make sure that we have the derivative of the argument next to it. So the derivative of 4x is just 4, but then we don't want to change our equation, so we'll multiply by 1 over 4. So yeah, from there we are going to just ask ourselves a simple question. If we have the derivative of the argument alongside with this trig function, then we can ask ourselves, what is it that was differentiated for us to get positive sec squared? What is it? It is tan of 4x for this case, right? So we're gonna take whatever that we have outside the argument, outside the integral. So we're gonna take that 1 over 4. So it's gonna be this 1 over 4 multiplied by what? So it's gonna be multiplied by tan of 4x, tan of 4x, and then from there we integrate this 1 here. So when we integrate 1 there, we should get something like just minus x and then plus c. Then ta-da, we have our answer there. So yeah, That's just it. That's just it for this case. And then yeah, of course you can always differentiate your, what is this, your answers to see if you're gonna go back there. So for this case, when we differentiate this, of course it's going to be sec squared multiplied by 4 and 4 and cancel each other. Different this, it becomes 1, and then sec squared minus 1 is equivalent to tan squared. Yeah, and then that's it. So that's how to verify the answers. Anyway, let's quickly do some other questions. We still have more questions to discuss. So now we've got this. We've got the integral of sine of x multiplied by cos of cos x. So this one looks like it's tricky, but it's simple, right? So guys, remember to pause the video so that you can work out on this problem by yourself, that side, and then resume later to check the memo, of course. So when we have this, so it is the same thing. With our main function, our main focus here has to be this cos and its argument. So the argument here, it's cos of x. So we ask ourselves, what is the derivative of cos of x? It's negative sine of x, right? And then here we can see that we have positive sine of x. So we need to make sure that we've got the derivative of the argument there. So the argument is cos of x, and the derivative of it has to be negative sine of x. So we need to then rewrite this nicely into this following format. So this is going to be negative sine of x multiplied by cos of cos x dx. So our trig function is this one, and then the argument is cos of x, and then the derivative of cos x is what? It's negative sine x. But then I didn't have negative there, I just cooked it. So to make sure that I don't change the equation, I need to then multiply by another negative outside there. So if I have the derivative of the argument alongside a certain trig function, then what do? I ask myself, what is it that was differentiated for me to get this positive cos? I repeat, this positive cos. So when I ask myself, I find that it was, for me, the thing that was differentiated for me to get positive cos was what? Was positive sine, right? So positive sine was differentiated for me to get this. So positive, so I have to take this negative, yeah, along to my answer. So I take the negative outside there to my answer, and then I ask myself, what is it that was differentiated for me to get positive cos? It was what? Positive sine. So I then write sine of that argument, which is cos of x, and then you close, then plus c. Ta-da! You have your answer. So that's just it. Simple as that. Simple as that. So yeah, I hope you got it as well there, because I said the movie time, it's over. So now you're working on these problems as well. So now let's quickly continue and solve as many problems as we can. So yeah, we've got this as well. So we need to rewrite this nicely first, because we can see that it's not in a nice way. So to rewrite this nicely, we just say the following. So we're going to make use of reciprocals, because we know that 1 over cos is equivalent to what? To sec, right? So we're going to rewrite this, sorry. So the x that's up there multiplied by 1 over cos, I say this equivalent to which reciprocal? It's a sec. So this is going to be sec squared for this case. So this is going to be sec squared of x squared, sec squared of x squared dx. So remember, for us to be able to make use of those integral formulas, we need to then make sure that there is the derivative of the argument next to our trig function. So our trig function for this case, it's sec squared, and then the argument is x squared. So what is the derivative of x squared? It's what? It's 2x, but then we only have x here. So what do? We cook it. We cook this x until it becomes 2x. So for it to become 2x, we just need to put a 2, right? And then we cancel this 2, because if we just write the 2, then we're changing our equation, and our goal is not to change this equation, right? So to cancel this 2, we then multiply by 1 over 2, and then 2 and 2, they're going to cancel out. Then ta-da, we still have the same equation that we are trying to solve. So now that we have the derivative of the argument alongside with this trig function, what do? We then ask ourselves, what is it that was differentiated for us to get sec squared, right? So positive sec squared for this case. So you think, then you'll come to a conclusion that it was positive tan, right? That was differentiated for us to get sec squared. So you're gonna take this 1 over 2 to your answer because of it's part of the thing. So this is going to be 1 over 2. The thing that was differentiated to get positive sec, it's what? It's tan of that argument, which was x squared for this case, then plus c. Ta-da! You have your answer there. So that's just it. Simple, right? Simple as A, B, C, D. And then wow, let's do the following one. I hope you are getting this. I hope you are getting the same answers as me, guys, because you have to be getting the same answers. Otherwise, if you're getting something else, then what are you doing there? Whatever that you're doing is wrong, okay? So please make sure that you get the same things as I do here. So let's see this one. So this one we've got the integral of cos of 2x divided by square root of sine x cos x dx. So for this one, we can see that definitely we have to make use of general power rule. Why? Because there is nothing that we can conclude and say something was differentiated for us to get this complicated thing. No way. The way it is, we can't conclude like that. So we need to make use of general power rule, and then that will be it. And then so in most cases in your exam test, this is how it's gonna come. It's not gonna come in a simple way. It's gonna come in a way that you make use of general power rule alongside with integration of trig functions. You understand? So that's how it's gonna come. So this is the type. This is an exam type question or test type question. So let's rewrite this in a nice way first so that you and I can see what is going on. So let me write this cos of 2x, and then I want to take that thing up there. So we can see that sine of 2x is what? Sine of 2x is the same, is the half. Is half of what? It's half of the double angle. So this is the same. So sine 2x, sine x cos of x is the same as 1 over 2 multiplied by 2 sine of x cos of x. So what did I do here? I multiplied by 1 over 2 and 2. That means I multiplied by 1 because 2 and 2 they cancel out. But then if I don't make them to cancel out, then 2 sine x cos x becomes the double angle, right? Becomes sine of 2x, and then the 1 over 2 outside. Hence I said sine x cos of x is equivalent to 1 multiplied by the double angle of sine. That's what I said before. So allow me to just put 1 over 2 sine of 2x here. Sine of 2x to the power negative half. Let me just erase this thing because I don't know what it's doing there. erase you, man. Yeah, and then dx, so I shouldn't forget my dx there. So what do we have here? What do we have here? So look at this. if 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 we let 1 over 2 multiplied by sine of 2x to be our f of x, can this be f prime of x? Yes, because of if we differentiate sine 2x, then this becomes cos of 2x multiplied by 2, and then that 2 will cancel out this 1 over 2, of course. Then this will become just cos of 2x, right? Makes sense, right? So if I have if this become f of x and this becomes f prime of x, and then we can see that our f of x is to the power n, then we can make use of general power rule, right? We've discussed a lot of general power rules, so if you have forgotten about it, you can just quickly go back to the previous activities. You'll see, you'll remind yourself there with the videos there that I've made. So yeah, if I have f of x and f prime of x, and if my f of x here is to the power n, which is not equivalent to minus 1, then I can just use general power rule. Otherwise, if my n here is -1, then I need to make use of general log rule. So yeah, then this means that the answer for this is just going to be the following. So it's just gonna be 1 over 2 sine of 2x to the power -½ plus 1. So that's going to be positive half divided by positive half, and then plus c, and then yeah, that's just it, and then that will be just it. And then one could say, I want to simplify this, so square root of, so here you have square root of 0.5 divided by 0.5. This could just become square root of 2, of course. So here one could just say this is the same as 2 multiplied by square root of 1 over 2 sine of 2x plus c. Then ta-da, you have your answer there. So you can always just differentiate this answer to see if you'll get back there. So yeah, you don't have to stress about this. So yeah, that's just it. I can't say something else here. So yeah, that's just it. I hope we both got the same thing. So let's quickly check if we can differentiate this following question. I hope you also got the correct answer. So yeah, another question here, we've got 1 divided by cos of 2x multiplied by cot of 2x. So what is it that we're gonna do here? We can see that there is definitely nothing was differentiated for us to get 1 over this complicated thing, right? So meaning that we need to rewrite this in a nice way. So for us to do that, this is what we're gonna do. The procedure is gonna be as follows. So we're gonna make use of our reciprocal. So 1 over cos, 1 over this. So 1 over cos, what is it equivalent to? It's equivalent to sec, right? So this is going to be equivalent to sec of 2x, right? Sec of 2x. And then multiplied by 1 over cot. What is it equivalent to? In terms of reciprocal, it is tan of 2x, and then the x. And then now that we have sec of x, tan of x, we can see that definitely something was integrated for us to get, or something was differentiated for us to get sec tan, right? So, but before we could conclude, we need to make sure that we have the derivative of the argument next to this whole thing. So the derivative of 2x, what is it? It is just a 2, right? It's just a 2, but then the 2 we didn't have it in our equation, so we need to cancel it out by multiplying by 1 over 2. Then if we have the derivative of the argument alongside this trig function, these trig functions, then we can conclude that the thing that was differentiated for us to get positive sec tan was what? Was positive sec, right? So this is going to be, so this 1 over 2 that's outside will go to the answer, and then also the thing that we get here when we have asked ourselves, what was it that was differentiated for us to get sec tan, then we find that it was just a sec of 2x plus c. Then ta-da, you have your answer there, and then that's it. Nothing else. All right, I hope you got that one. I hope you got it, because it was easy, right? What did I do now? Okay, now we've got sine divided by 1 plus cos of x. Then, okay. So in cases whereby we have quotients, I should have maybe spoken about this earlier. I'm sorry for that, but it's simple, guys. It's simple. So here we can see that there is nothing that was differentiated for us to get sine over 1 plus. That means we need to do something to this. We need to cook. And for us to cook, since we have a quotient, then it takes us back to that, what is this? To that video. Is it activity 2 or 3 there? I think it has to be activity 2 or 3 under integration there, whereby I was explaining different cases for solving different types of quotients. So when you have a quotient is a fraction, so don't be confused by the word quotient. So a quotient is a fraction. So when you have a quotient, you need to always look for the use of general log rule and the general power rule. So general power rule and general log rule, the only difference between them is that n1, for the other case, n should be equals to -1, and for the other case, n should not be equivalent to -1. So if it's equivalent to -1, I mean, then it's a general log rule. If it's equivalent to something else, not -1, then it's a general power rule. So this is, we're going to apply the same thing here. Because of we can't simplify here, we can't do anything, so we need to then check, can we make one f of x and the other one f prime of x? So for this case, if we make 1 plus cos of x, this thing of f of x, then can the numerator be f prime of x? Yes, because of when we differentiate 1 plus cos of x, we get 0 minus sine x. So we do have sine x. The only thing that will be left will just be cooking sine x into what we want it to be. So yeah, that's just it. So because of here, we can simplify this. Also, don't confuse this thing with that one of multiplying by the Pythagorean conjugate. The one of multiplying by Pythagorean conjugate is the one whereby on our numerator, we should have a constant. We should have a constant. So it's going to be a certain constant divided by a constant plus a trig function here. So that's the case whereby we multiply by 1, and that 1 should be a Pythagorean conjugate. So for this case, we're not going to do that because of on our numerator we don't have a constant. Instead, we have a trig function. So we need to just simply say if we let 1 plus cos of x to be our f of x, then this is going to be our f prime of x. So for it to be our f prime of x, then we need to put a -1 there next to it. So let's rewrite this nicely. So if we let 1 plus cos of x to be our f of x, then the derivative of this must be negative sine of x, right? So because of we didn't have this negative, we need to cancel it out by multiplying by a negative thing outside there. So our n for this case is going to be equivalent to 1, right? So if our n is equivalent to 1 and it's in the denominator, then we need to make use of general log rule. If you're confused by that, kindly check the previous videos, remind yourself of what's happening there. So yeah, then we can then conclude if this is f of x and that's f prime of x, then we can just conclude that the answer for this is just negative ln of 1 plus cos of x plus c. Ta-da! We have our answer then. That's just it and nothing else. And then yeah, I hope you got the same thing, Ezra. I hope you got the same thing, because you should get the same thing. Let's see what we can do to this question then. Let's see what we can do to this question. So now we've got the integral of cos dx. So this is a case that we were trying to discuss up there that this could be done in 2 ways. Maybe for this case I'm just gonna solve it in both cases, right? So for this case we can say that nothing was integrated for us to get this quotient, right? So we can't just say the integral of this is sine, it's whatever, without us having to rewrite this in a nice way or trying to simplify first, something like that. So this could be done in 2 ways. One could go with the way of using our general power rule, because our n for this case is going to be equivalent to -2. One could just say, no, I don't have to do that. I can just split this and make sure that I have something like what I'm going to write here. So one could just say I can split this into 1 multiplied by cos of x. And then I split the signs into 2. So this is going to be sine of x multiplied by sine of x, and then dx. So from there, that person is going to conclude and say 1 over sine is equivalent to what? To cosec, right? So this is going to be equivalent to cosec. Cosec of x multiplied by cos over sine. What is it equivalent to? It's equivalent to cot of x, the x. And then that person will then conclude that since the derivative of x is 1, the one that I have here, and I know that the thing that was differentiated for me to get cosec cot, it's what? It's negative what? So for this case, it's going to be negative cosec of x, right? So then that person will just conclude that the answer for this is negative cosec of x plus c. Then ta-da, that person has the answer. And then one could have just said, no man, I want to rewrite this in a nice way. So to rewrite this in a nice way, I will write it in this format, and then cos of x will be multiplied by sine of x to the power -2 dx. So that person is going through the general power rule route, right? Because of, if ever I let sine of x to be my f of x, then can this be the derivative of f of x? Can cos of x be the derivative of sine of x? Yes, it can be. So if I have f of x and the derivative of it, and then my n here is equivalent to -2, then I can just make use of general power rule. So then my answer here is going to be sine of x to the power negative, so -2 plus 1 is going to be equivalent to -1 divided by -1 plus c. So at the end of the day here I have something like -1 divided by sine of x plus c. If I take sine x down there, and then I will end up giving this. So 1 over sine is what? It's equivalent to cos x. So at the end of the day, this is going to be the same as the other methods. It's going to be cos x of x plus c. Then ta-da! Both these people, they would have gotten the same answer using different approach. Makes sense? So yeah, in integration, you can kill a cat in a lot of ways. One can decide to kill it by using a gun. One could just slap it, and then ta-da, you have your answer. So yeah, anyway, let's not waste time and quickly check out the questions. So that was it for that question. So let's see if we can solve another one. Okay, I hope you got that one. It was an easy one. It was an easy one. Really, it was easy. So easy, you know. It was so easy, you know. Okay, so now we've got ourselves this question: integral of cos x minus sine x squared. So what are we gonna do here? Just because of, we can see that there is nothing that was differentiated for us to get cos minus sine squared. Nothing at all. So we need to simplify this. We need to simplify this by multiplying out. So by expanding, since we have the squared, we can just expand this into 2 brackets, and then at the end of the day, we're gonna have something that looks like what I'm gonna write here, which is gonna be cos squared of x minus, so I don't know, I'm jumping steps. Let me not jump steps, because someone will say, yeah, this guy now is taking chances. I don't want to take chances on you guys. So let's just write it in this format. So it's going to be cos of x minus sine of x multiplied by cos of x minus sine x, and then dx. Just like this. And then from there, we're going to multiply this bracket and that bracket. So I expanded this thing into 2 brackets because of where the square. Then I'm going to multiply this bracket and that bracket. We should get something like what I'm going to get here. So this is going to be cos squared of x minus 2 cos x sine x, 2 cos x sine x plus sine squared of x, and then dx, of course. Yeah, that's it. And then dx. But then cos squared plus sine squared is equivalent to 1, right? So I can just simplify this further again and say that I have 1, and then 2 cos x sine x is a double angle, so I can then also say I have a double angle of sine of 2x, and then dx. Otherwise, if you don't do this, then you'll need to substitute your half angle identities into this cos, and then your half angle identities again into this sine squared. So that is gonna be long. So for you to simplify your life, you need to just say cos squared plus sine squared is equivalent to 1, and then you change this double angle into this. So yeah, then from there it's gonna be easy for us to integrate. I can just split this. I'm gonna have integral of 1 dx minus the integral of sine of 2x dx, just like that. And then from here, okay, the integral of 1, that one is easy. Even me, I can answer that in my sleep. Like when I'm sleeping, you can just ask me, what is the integral of 1? I'm gonna tell you it's x. I don't have to worry about that. It's well crammed. Even after 10 years, you can ask me, what is the integral of 1? I'm gonna know. But the integral of sine, definitely, I might not know. After 10 years, if I'm not doing maths again, it will be gone. Even you, right? Or will you remember it? Anyway, let's get back to maths. Why is my mind going away when I'm solving this thing? I guess maths is not a nice thing, eh? Yeah, so this goes back to where we started. So we need to make sure that whenever we're integrating any trig function, next to it, there should be the derivative of the argument. So what is the derivative of 2x? It is just a 2. It's just a 2. But then we didn't have this 2 in our equation, so we need to cancel it out by multiplying by 1 over 2 outside the integral. So now we can integrate this. So the integral of 1 here for this case is just gonna be x, and then minus this 1 over 2, which is outside the integral. Then we ask ourselves, what is it that was integrated for us to get what is it that was differentiated? What is it that was differentiated for us to get sine? Positive sign for this case. What is it? It is negative cos, right? So a negative cos was differentiated. So this here you're gonna come and say negative cos of 2x was differentiated for us to get positive sign, and then plus c. Then of course we can simplify this further and say this is equivalent to x plus 1 over 2 cos of 2x plus c. Then ta-da, you have your answer. Then that's just it. All right, I hope you got the same thing, guys, because you cannot afford to get different things to what I'm getting. If you are affording that, then you must be rich, eh? You must be very rich. Let's see. So now we've got ourselves another integral equation, which is as follows: sine x plus cos x divided by cos of x dx. So what can we do? Simple, right? We can say that whenever we differentiate something, we cannot get this complicated quotient when we differentiate that something. So that tells us that we need to just rewrite this in a simpler way first. So to rewrite this, you then come and say you're gonna give each and every numerator term its own denominator, meaning that we'll end up having sine of x divided by cos of x plus, or I can just split them same time, right? I can just say dx here plus the integral of cos of x divided by cos of x dx, and then bam, and then what am I doing? Sine x divided by cos x, what is it? It's a tan, right? It's a tan. Of course, one could say I can use general power rule, or okay, we can just leave this one like this. Yeah, let's just leave this one like this. It's very entertaining when we leave it like that. But then cos of x divided by cos of x, it's a 1, right? So let's take that one further and leave this one like this. I feel like it's well interpreted when it's like this, right? So cos of x dx plus the integral of 1 dx. So this one, we come to it. So if here we let our cos of x to be our, so if we let our cos of x to be our f prime of x, our f of x, I mean, can this be f prime of x? Yes, because of when we differentiate cos of x, what do we get? We get negative sine of x. So meaning that our sine of x is incomplete. There should be a negative sign there, so we are going to put a negative and a negative outside here, and then we're gonna get what we really want. So if f of x is on our denominator, then our n for this case is going to be equivalent to a 1. So if we have our 1 as our n, and then this is f of x, then we can just make use of general log rule, because this is going to be the derivative of this. So then from there, we're going to conclude that the thing that was differentiated for us to get this, it is natural log, right? So we're going to make use of general log rule. That's what I'm trying to say. We're going to get negative ln of what? Of cos x. ln of cos x. ln of ln of cos x. That's what I'm trying to say. ln of cos of x, and then plus x, then plus c. Ta-da! We have our answer. Also, one could have just said that so this could be done in two ways. One could have just said that the integral of, one could have just changed this sign into what? In sine, I mean, one could have just changed sine x over cos x into tan, right? You understand? So that, okay, here I'm doing the OR thing for this, ne? So let's do the OR thing for this. So or it could be the integral. So if you change sine there, sine x over cos x, this is going to be tan of x dx, and then the integral of your thing there, the integral. So the derivative of x is 1, right? So we can just argue and conclude that the thing that was differentiated for us to get tan, it's what? It's just ln of sec of x, and then plus c. You understand? So these two things, they are the same things, guys. When you differentiate them, you'll get back to the same thing. You understand? Because when we differentiate this, you're going to get negative sine x over you're going to get negative sine x multiplied by this negative divided by cos x, which is the same thing. And then when you differentiate this, you're going to get sec x tan x divided by sec x. Sec x and sec x, they're going to cancel out. You're going to go back to the same thing, tan x there. So it is the same thing. It's the same thing. Same thing. So yeah, that's what I'm trying to say. So yeah, it's up to you what you do. So all in all, I can also just remind you that in integration there could be two different answers that looked different, of course, but they are the same. They are correct answers for the same differential question, integral question. You understand? What I'm trying to say in short is that you can have one integral question and it can have two different looking answers. You understand? So yeah, well, I just demonstrated that using this and this. Makes sense, right? So yeah, it does make sense. Okay, remember, it's not a movie, guys, it's a lesson. So this lesson, you solve, I solve. That means we're both solving equations here. So let's see. Now we have this question. What can we do on this question? Asking you, I'm asking you, what can we do on this question? So we can see that definitely there is nothing that was integrated for us to get 1 over something. So we need to rewrite this in a nice way for us to be able to see what is it that was differentiated there. So this is going to be the following, right? So we are then going to conclude that 1 over cot, it's what? It is tan, right? I'm changing it into its reciprocal. So this is going to be e to the power x multiplied by tan squared of e to the power x dx. So what did I do there? I changed 1 over cot squared into its reciprocal, which is going to be tan squared. Then from here, I'm going to change tan squared again into what? Into what is equivalent to using the square identities, right? Because why am I doing that? Because there is nothing that was ever or that was differentiated for me to get tan squared. So that means I still need to do something to this equation for me to be able to integrate it. So to do that, I need to just change tan squared into what is equivalent to when I make use of the square identity. So I'm going to put this e to the power x and then change the tan squared into sec squared of e to the power x minus 1 and then vx. And then I multiply the two there. I should get something like e to the power x multiplied by sec squared of e to the power x minus e to the power x, and then dx. So what did I do? I multiplied e to the power x with each and every term that's inside the brackets there, and then I got what I got there. And then from here I can decide to split if I want to do that, but then yeah, let's do it to avoid confusion. To avoid confusion, e to the power of x multiplied by sec squared of e to the power x dx minus the integral of e to the power x dx. Okay, so yeah, from here we have this. So we've got this e to the power x, which multiplies sec squared of e to the power x dx minus the integral of e to the power x. So remember, we need to make sure that we have the derivative of the argument next to the trig function, so which multiplies the trig functions in a more correct way. So the derivative of e to the power x remains as e to the power x, right? And then if we have the derivative of the argument next to this trig function, then we can then conclude and ask ourselves, what is it that was differentiated for us to get sec squared, positive sec squared? What is it? It was just tan of that argument that we're dealing with there. So this the argument for this case is just gonna be e to the power of x. Then we move to our guy here, which never changes whether we're integrating him or differentiating him. He remains as that guy. So the thing that was differentiated for us to get e to the power x was e to the power x, and then plus c. Ta-da! That's the answer for our thing. And then now we've got this guy. So guys, please make sure that you have also writing these questions as I write them, right? So please make sure you are also trying to solve them as I solve them as well. So yeah, that's just it. That's just it. So look at it. Now we've got this guy. So where I wrote this, so this dx, guys, this one that I canceled there is not supposed to be there. It's just a typing error. So please please regard it as not being there. Regard this dx which I canceled being not there, you understand? So yeah, it's just the typing error, guys. We are sorry for that. Apologies. Kubam Twarelo. Yeah. So what is this? So now this means that we've got, let me rewrite this nicely because that one is disturbing me there. So now this means that we've got 1 minus sine of x dx. Okay, so there is a dx here. Let me just write it here for the sake of what I want to do to this question. So because of I have a constant divided by a constant plus minus trig function, what do? I said I need to make sure that I multiply by a 1, but this one should be a special one, which is gonna be a Pythagorean conjugate. So a Pythagorean conjugate just means that you just change the sign that's between that constant and the trig function, and then that will then means that we are going to multiply by 1 plus sine of x divided by 1 plus sine of x, just like this. And then this is how it's gonna be like. And then from there we need to multiply the numerator and the numerator, denominator and the denominator. We are then going to get, what I'm gonna get there is 1 plus sine of x on our numerator. What is this guy doing? Sine x divided by, then we multiply the denominator and the denominator, we should get something like 1 minus sine squared of x dx, just like that. And then from there we are going to change this 1 minus sine squared into its equivalence when it comes to the square identities. So we are going to get 1 plus sine of x divided by what? Cos squared of x dx. There, just like that. And then from there, what are we then going to do again? We need to split. So we're going to make each and every numerator term to have its own denominator, meaning that we'll end up having the following. So we'll end up having 1 over cos squared of x dx plus the integral of sine x divided by cos squared of x dx. Makes sense, right? So of course this could be done in two ways. We have discussed this type of shape, whereby one could say I want to use a general power rule. One could say that I can just split this cos into 2 and then use the reciprocals. Let's just go with the reciprocals method. I prefer that one for this case. So 1 over cos, let's also change it into its reciprocal. So 1 over cos is going to be what? Is going to be equivalent to sec squared of x for this case, dx. So I changed the 1 over cos into its reciprocal because we can't integrate 1 over cos. So yeah, we need to simplify it by changing it into its reciprocals, and then this guy is just gonna be 1 over cos of x multiplied by sine of x divided by cos of x dx, just like that. And then from there 1 over cos, and then sine x over cos x. We can change this. So this is going to be, let's not integrate, we're going to integrate all at once. And then dx plus, so 1 over cos, what is it equivalent to? In terms of its reciprocals, it's going to be equivalent to sec, right? So we're going to get sec of x here. We're going to get sec of x, and then sine over cos is equivalent to tan of x, and then vx. So now we can integrate. This is in a nice simple way. So x is our argument, so the derivative of x is 1. 1 is there, so meaning that we can proceed with integrating this. So we can just ask ourselves, what is it that was differentiated for us to get sec squared? What is it? It's a tan, right? So tan was differentiated for us to get the sec squared. So this is going to be just the positive tan of x. And then we move to that guy there. We take this positive there, which is this sign. This to there, this to there. And then our argument for this case is x. So the derivative of x is 1, the one that we have here. So now we ask ourselves, what is it that was differentiated for us to get sec tan? It was what? It was just a sec, right? Positive sec. So this is going to be positive sec of x plus c. Ta-da! You have your answer there. Then that's just it. That's just it. All right. All right, then we move. We move. All right. Now let's see what we can do to this guy. So now we've got the integral of cot of x, ln of sine x dx. So what can we do to this question? We check, is there something that was differentiated for us to get this complicated thing? Then definitely, and no. Then we must think of something else. Okay, so can we simplify this? Definitely, and no. Even if you can change a chord, it can't help you with like anything as something cancelling out there. It cannot help. So can we make one f of x and the other one f prime of x? So which thing can we then make f of x and the other one f prime of x? So if we let ln of sine x to be our f of x, can cot of x be f prime of x? Yes, but then for you to agree with me, I need to rewrite this in a nice way first. So this is going to be cot over cot x is what is equivalent to cos x is equivalent to cos of x divided by sine of x. That is just the equivalence of cot of x multiplied by, so I'm rewriting this in a nice way so that me and you can agree on one thing, okay? And then this is to the power of 1 dx. Look at how nice it looks, right? It looks nice, right? Isn't it? It has to look nice. If you are seeing something that is not nice now on your screen, then there should be something with your eyes, something wrong with your eyes. You need to get the, what do they call them? The specs, something's there, something specs there. So yeah, now I'm just trying to convince you that if we let this to be our f of x, then this is going to be our f prime of x. In what way? If we let ln of sine x to be our f of x, then we know that the derivative of ln, every time we have to put a fraction, right? And then on our denominator, we put the argument. So this is going to be sine x, and then on the numerator, you differentiate that argument. So this is just going to be, the derivative of sine x is just going to be cos of x. And then cos of x sine x, which is what we have here, right? Meaning that we have f of x alongside with its derivative, right? So, and here our n is equivalent to 1. in this format. So meaning that we can just use general power rule. General power rule. So this is then going to be equivalent. If this is f of prime and this is f of x, then we can conclude that our answer is just going to be sine of x to the power of 2, because you're going to add 1 there on 1 and then divided by 2 plus c. And then that's just it. One could just say, I want to rewrite this again in a nice way further. This is going to be equivalent to 1 over 2 ln squared of sine of x plus c. Then ta-da! You have your answer to that question. So yeah, that's just it. That's just it. I hope you get I hope you got it. I hope you got it. It was very, very simple. So yeah, let's quickly see another question there and do something to it, like destroy it. Okay, now we have ourselves this question, which is 1. So forgive me for that dx, this one. Please regard it as not being there, okay? Regard it as a 1 here. Don't, please, it's not there. It's just the typing error, So it's not there, please. It's not there. So this is the same. It's 1 over tan squared of 2x. So 1 over tan squared of 2x, like we can't conclude directly to it that something was differentiated to get 1 over tan squared. It's not there. There is no way. So we need to first rewrite this in a nice way and then make conclusions after that. So to conclude, we need to first rewrite this nicely by making use of reciprocals. So 1 over tan is equivalent to what? Cot squared. Cot squared of what? So this is going to be equivalent to cot squared of 2x dx. Still, when we check cot squared, there is nothing that was ever differentiated for us to get cot squared. That means we still need to cook. For us to cook, we need to make use of our square identities. So we need to make use of our square identities and write the equivalence of cot squared with regards to the square identity. So we know that cot squared is equivalent to what? To cos x squared minus 1. So cot squared is equivalent to cos x squared minus 1. So this is equivalent to cos x squared minus 1 according to the square identities. So you must have crammed your formulas for you to survive somewhere, somehow. So yeah. And then from here, we're going to split this so that each term have its own has its own integral. So this is going to be cos x squared of 2x dx minus the integral of 1 dx. Then we ask ourselves, okay, definitely this one we can say that something was differentiated for us to get cos x squared. But then we can't make that conclusion without having the derivative of the argument next to this trig function, right? So what is the derivative of 2x? It's just a 2. But then we didn't have the 2, so we need to cancel this 2 by multiplying by 1 over 2. So from there, we then conclude that if we have the derivative of the argument together with this trig function, then we can conclude that the thing that was differentiated for us to get this whole thing was negative cot, right? So it's going to be negative cot. So that negative cot has to go with this 1 over 2. So it's going to be negative 1 over 2 cot of 2x, right? Negative that cot of 2x, and then we differentiate this 1, we integrate 1, is just gonna be negative of x, and then plus C. Ta-da! You have your answer there, and that's just it. Simple like that. And then we move. Okay, now we've got the integral of sine 2x divided by the square root of 1 minus cos of 2x dx. We can see that definitely there was nothing that was differentiated for us to get this complicated quotient, meaning that we need to do something, we need to cook, yeah, for us to be able to integrate this. So because of we cannot simplify, by simplifying I'm referring to we cannot say if we do something to this then something might, so certain things could cancel out something. Perhaps I can say if I can change this double angle then maybe it can cancel out with this, and then things gonna be simple. So since we cannot be able to do that in a way that this thing will end up being simple, of course we can change this into a double angle, like 2 sine x cos x, but will that help us? So it can't. So if it can't help us, then we can conclude that we cannot simplify this. So what if we can't simplify, then we need to check if we can let one thing to be equals to f of x and then the other one be equivalent to f prime of x. So you're gonna check, yeah, if we let 1 minus cos 2x to be f of x, can this be f prime of x? Of course it could be f prime of x, but then it's not nice, it's not written nicely, it's incomplete. So we're gonna cook there from there. So let's rewrite this nicely into this following format. So we're gonna have sine of 2x, which is multiplied by 1 minus cos of 2x to the power negative half dx. So what did I do here? I changed this root and I took it up, and then it changed the exponent into negative half, and then everything remained the same there. I didn't do anything to the rest. So I was saying that if we could let 1 minus cos of 2x to be our f of x, can this be f prime of x? Yes, because of when we differentiate 1 it becomes 0, but then when we differentiate negative cos of 2x it becomes negative multiplied by sine of 2x, or negative sine of 2x, and at the end of the day we're gonna have positive. That's what I'm trying to say. So it's gonna be this negative. Okay, when we differentiate this, let me do it down here so that you can see. It's gonna be this negative multiplied by the derivative of cos has to be another negative, and then sine of 2x, right, multiplied by a 2. So this negative and the negative, they will form a positive that, right? So we already have positive this. The only thing that's missing is a 2, right? So we need to cook that 2. So to cook that 2, you just put it. You just put a 2 and then you cancel it out by putting another 1 over 2 outside there. And then from there, we make use of our general power rule, because of our n here is not equivalent to negative 1. So then that means we should use general power rule, right? So yeah, we're gonna have this 1 over 2 outside, and then we apply our general power rule here. We're gonna have 1 minus cos of 2x to the power negative half plus 1, that becomes positive half, divided. So we're going to divide this whole thing by a half, and then plus c, and then the 2 and 2 are going to cancel out, and then we will end up just having square root of 1 minus cos of 2x plus c. Then ta-da, you have your answer there. So simple as that. There's nothing tricky there. There's nothing tricky. I hope you are not also not tricked, right? Because it could be not tricky, but tricky, still trick you. So please don't be tricked by things that are not tricky. So yeah, that's just it. That's just it. Now let's see what we can do to more guy here. Okay, now we have this guy. We have this guy. So what can we do to this guy? Okay, when we check this guy, definitely there is nothing that was differentiated for us to get this complicated quotient, right? So meaning that we need to simplify this or rewrite this in a nice way whereby we could see that this was differentiated for us to get this thing. You understand? So yeah. Let's what can we then do? Since we have 1 minus sine squared, okay, we can see that we can change 1 minus sine squared into its equivalence when it comes to the square identities, and that's going to be cos squared. So at the end of the day, what I'm trying to say, we can take we can take the 2 out, and then we're gonna have this what is this, 1 over cos squared of x dx. Oh, not dx. What am I doing? Got chance, eh? All right. To the power 1 over 2 dx. All right. So this is going to be okay. So what did I do here? I changed this root into into an exponential form, kinda, and then I changed 1 minus sine squared into cos squared. Again, I need to change 1 over cos squared into its equivalence when it comes to the reciprocals. So this is going to be 1 over cos squared is equivalent to sec squared. Sec squared of x multiplied by tan of x to the power 1 over 2 dx. So now this thing is nice, right? Look at it. Look at how nice it is. So we can see that if we let tan of x to be f of x, then this is gonna be our f prime of x, and then also our another thing here, our n is equivalent to 1 over 2, so meaning that we can use general power rule. So the derivative of tan x is just sec squared of x, which we have here. So that means for us to have our answer here, our answer for this thing is just going to be the 2 that's outside multiplied by application of general power rule. Here is just going to be tan of x to the power 1 over 2 plus 1 is just going to be your 3 over 2 divided by 3 over 2 plus c. Then tada, you have your answer. Of course, one can argue and say, nah, I want to write this in a nice way. So let's then write this thing in a nice way for the sake of avoiding some arguments. So this is going to be 4 over 3. The 2 is going to go up there and multiply with that 2. And then we can change this 3 over 2 into a square root. And then this going to be the square root of tan cube of x plus c. Then tada, you have your final answer. Wow, must be nice, eh? It is nice. Must be nice. Okay, so now let's check this question, guys. Remember to pause these videos and then solve these problems on your own, and then resume later to check the memo, of course. So now we have this question. What do you think could be done here? What do you think could be done? So this could be done in different ways. One could say that I can just okay, I'm gonna do it in two ways because of I can see what could be done already. So one could say I can just change uh just change these things, just change cosec into what, into its reciprocal. So 1 over cos, I mean 1 over cosec is gonna be equivalent to sine, right? And then from there, basically let's just change everything into sine and cos. Yeah, let's just change everything into sine and cos. I don't want to complicate the thing. Otherwise, if I do it in the other method, it will then mean that I've done this other method that I haven't done with you guys, which is for other activities. So for now, let's just stick with simplifying this. So the best way to simplify this is to just change sec and cos into their reciprocals. So meaning that we're gonna end up having something that looks like this. So 1 over cosec is equivalent to what, to sine, right? To sine of x. And then is it nice like this? I don't know, is it nice? Now let's not change it like this directly. I don't want to confuse you and myself as well. Yeah, I don't want to confuse myself as well. Cosec of x multiplied by sec sec of x to the power of 5 dx. So what can we do here? We can make use of reciprocals. So 1 over cos, what is it equivalent to? 1 over cosec is equivalent to sine, right? 1 over cosec is equivalent to sine. So this is going to be just sine of x. So sine of x multiplied by, so cos sec itself, it's equivalent to what? To 1 over cos. So inside here, I'm going to have 1 over cos of x to the power of 5. And then I rewrite this nicely again. I'm going to say sine of x multiplied by cos of x to the power -1 all to the power of 5. And then yeah, I forgot the dx. Why? I think it's because of I might be tired, maybe, or maybe crazy. I don't know which one is that one. So yeah, then from here we're gonna apply our properties of exponents or laws, or I don't know what is it. Is it algebra? Whatever that thing. We're gonna multiply this -1 with that 5. We're gonna use that rule of multiplying. Is it laws of exponents? Yeah, I think it's laws of exponents. We're gonna apply our laws of exponents. There we're gonna have cos of x to the power -5, and then dx here. Makes sense, right? Yeah, it has to make sense. Otherwise, if it doesn't make sense, there's something wrong with you. Okay, so now we can see that this thing is nice, right? Look at it, just look at it, it's nice, right? So if we can let cos of x to be our f of x, then can this be f prime of x? Yes, but then it's incomplete. So it's incomplete because of when we differentiate cos of x, we get negative sine of x. So this thing is not negative, so we need to put negative and negative. So if I have my f prime of x and my f of x to the power n, which is -5, then I can make use of the general power rule. So let's apply it. We're going to take this negative outside, and then we apply our general power rule. This is going to be cos of x to the power -5 plus 1. -5 plus 1 is going to be -4 divided by -4 then plus c. And then one could argue that -1 divided by -4, that's equivalent to 1/4. So this is going to be 1/4, and then we take the cos down there, we'll end up getting 1 over cos to the power 4 of x plus c. And then 1 over cos, what is it equivalent to? It's equivalent to sec, right, in terms of reciprocals. So this is going to be the same as okay, let me write it here on the side. I'm sorry for that. So that's going to be 1/4 sec 4 of x plus c. Then ta-da, you have your answer. So that's just it, guys. That's just it. Nothing fancy. No, it is nothing fancy there. So I hope you got the same answer as well. I hope you got the same answer. So now we have this guy here. Let's see what we can do to him. Guys, remember to pause the video so that you can work out on these problems on your own as well, and then resume later to check the memo, of course. So why did I have this already? All right, so we've got x squared cos of that, x squared cos of x cubed minus 2 divided by sine squared of x cubed minus 2. X squared cos of x cubed minus 2 sine squared of x cubed minus 2. So when we check, there is nothing that was differentiated for us to get this complicated quotient. Remember, a quotient, I'm referring to a fraction. So then that means we need to simplify this or rewrite this in a nice way if it's possible. Of course, there has to be a possible way. Of course, it's possible, I mean. So I think now I'm tired, but anyway, let's continue. Let me stay strong, remain strong. I'm a soldier. Okay, soldiers are strong, eh? So we've got x squared multiplied by cos of x cubed minus 2. So what can we do to this? We can see that we need to make use of general power rule, because of there is nothing that we can say we can do to this, like maybe changing something into something there. It's not gonna help. So let's rewrite this in a nice way so that we can say that we must use general power rule. So we have got ourselves the x squared multiplied by cos of x cubed minus 2 multiplied by sine of x cubed minus 2 with close to the power of 2 dx. So we can see that if we can let sine of x cubed minus 2 to be our f of x, then this can be f prime of x, right? Because of when we differentiate sine of x cubed minus 2, we're going to get cos of x cubed minus 2 multiplied by the derivative of x cubed minus 2 with respect to x. That's going to be just 3x squared. But then we don't have 3x squared here, we only have x squared. So we can cook the 3. So we can cook the 3 and then multiply it by 1/3 so that we don't change the equation, right? So if we have f prime of x and f of x to the power of n, and our n here is 2, then we can make use of general power rule, right? So then this becomes this 1/3, which is outside there. So it's going to be this 1/3, 1/3. Oh, I'm doing a mistake, guys, just a minor mistake. This has to be -2. I'm very sorry for that. Like I've said, I think I'm tired, but let me try to focus, okay? Let me try to focus. So here we have -2, right? We've got -2 because of I took this sign up there, so it has to be there has to be an exponent of -2. I'm sorry for that. I don't know how I've lost focus. Maybe it's because of being tired. I've been doing this video for quite a long time. As you can see, this video is long. So I am tired, but anyway, let's focus. Let's remain focused. Maths needs people to be focused regardless of whether they are tired or not. So let's see, let's just confirm everything. If we let sine x cubed -2 to be f of x, then the derivative of this is just going to be positive cos multiplied by the same argument, or into the same argument, and then multiplied by the derivative of the argument, which is x cubed -3 with respect to x, is going to be 3x squared. So I put the 3 there, and then I put 1/3 out to cancel 3 and 3. And then from there, I can make use of general power rule because of my n here is equivalent to -2. So yeah, I can make use of general power rule. So to do that, I'm just going to say this 1/3, which is outside, 1/3, which is outside. So I'm going to take this 1/3, which is outside, multiplied by the application of general power rule there. I take my f of x, so sine of x cubed -2 to the power -2 plus 1, then that becomes -1 divided by -1, and then plus c. And then of course we can rewrite this nicely and say this is equivalent to -1, or so I'm just saying -1 divided by 3, 3 sine of what? 3 sine of x cubed -2 plus c. Then ta-da, you have your answer. Then that's just it. The answer is there. So yeah, I hope you got it as well. That was an easy one. Really, it was very easy. So yeah, just quickly check this one out, and then we do it together. Now you need to give it a try first before you could check how I did it, right? So you've got sine of ln of 4x squared divided by x dx. So when we check this thing, we can't really conclude that something was differentiated for us to get thing. We have to first rewrite it nicely for us to see what is what, right? Before we could conclude. So before we conclude, so let's first rewrite this nicely to make sure that we are satisfied with our conclusion. So this is going to be 1/x multiplied by sine of ln of 4x squared, okay, dx. So we can say that definitely something was differentiated for us to get sine. So before we conclude, we need to make sure that we have the derivative of the argument alongside this trig function, right? So we check. Now when we differentiate ln of 4x squared, what do we get? We get something like what is it gonna be? It's gonna be 4 times 2. What is it? It's going to be 8x divided by 4x squared. So that's going to be 2 over x, right? Yeah, this has to be 2 over x. 8 divided by 4, it's a 2. X divided by x squared is 1 over x. So that means the derivative of this ln of x is 2 over x, right? It's going to be 2 over x. But then I only have 1 over x. What do? I put a 2 here. And then because of I didn't have a 2, I cancel out that 2 by multiplying by 1 over 2, right? And then from there, if I have the derivative of the argument alongside this trig function, then I can then conclude and ask myself that what is it that was differentiated for me to get this positive sign? So it's negative cos that was differentiated for me to get this positive sign, right? So I'm going to take this 1 over 2, which is outside, and then I say negative cos of the argument that I have there, which is 4x squared, then plus c. Ta-da! You have your answer there. So that's how we assess our self when it comes to these questions. So I hope you got it there. You got it as well. It was an easy one. All right. So now we've got our self-integral of we've got our self-integral of tan x divided by cos squared of x dx. So we can see that there is definitely nothing that was differentiated for us to get this complicated quotient, right? What does it tell us? It means that we should then cook by making use of reciprocals here, of course. So here we're gonna get this. So we're gonna get 1 over cos squared. So here there's gonna be 1 over cos squared of x multiplied by tan of x. Just trying to rewrite this nicely so that y'all can see what is happening. So yeah, so this is what's gonna happen. So we know that 1 over cos squared is what? It's sec squared. So this is going to be sec squared of x multiplied by tan of x to the power of 1 dx. So we can see that here there is nothing further that we can do, but then if we can make use of tan x as our f of x, then this could be our f prime of x, right? So this could be our f prime of x, because of when we differentiate tan, we know that we get sec squared of x, right? So also our n here is equivalent to 1, then we can make use of the general power rule. General power rule, of course. So yeah, let's start. So let's just apply it. This is just going to be tan of x to the power of 2 divided by the 2 plus c. Then ta-da, we have our answer here because of we have applied our general power rule. Simple as that. You have your answer. And then now we have this question here. So we've got the integral of sine x minus cos x divided by sine x dx, right? So what can we then do here? We can see that there is nothing that was differentiated for us to get this complicated quotient, right? So we need to simplify this first before we could make any conclusions. So to simplify, we need to just make each and every numerator term to have its own denominator. So we're going to split there. So this is going to look like something like sine x over x divided by sine x over sine x. I mean, what did I say there? Sine x over sine x, the let me just say dx same time. And then minus the integral of cos x divided by sine of x dx, just like that. And then from there, sine x over sine x, that's your 1, right? So this is going to be the integral of 1 dx minus the integral of So this one could be done in two ways, I guess, again, guys. So I'm gonna show you the two ways just for nje. Yeah, for just, yeah. So okay, let's leave that one in this way, just for the sake of, and then cos x sine x. Yeah, let's leave it like this, and then dx. Okay, so the integral of 1, that's just gonna be x minus, okay, so this one, if we let sine x to be our f of x, then this is going to be our f prime of x, right? So from here we can then conclude that since our n here is going to be equivalent to 1 and it's in the denominator, then we must use the general log rule, because of we have our f of x and f prime of x. So this is just going to be ln of what? Ln of sine x. Ln of sine x, and then plus c. Ta-da! We have our answer. So in the formulas, guys, in the formulas for trig, they've written for this integration, I mean, they've written that. So okay, what I'm trying to say is that one could have just said this thing, so this is the same as the integral of cot of x, right? Cos of is cos x divided by sine x. So this is what one could have said. So it is the same as, which is the same thing as what I'm doing. What I'm doing here is the same thing. So when you go to your formulas, you'll find that the integral of cot x is just ln of sine x. So in the thing, they'll just go to here. Otherwise, one could analyze it nicely like this, which is the same thing. So yeah, the other way that I wanted to do is just taking this to cot x and then going to the formulas. So yeah, that's what I wanted to do, guys. So that's just it. Let's not do it. And then now I have this other question, which is the following. Okay, now we've got ourselves integral of 1 divided by 1 minus sine of 1 over 2x. So this is a case whereby we have to multiply by 1, or we have to multiply by a Pythagorean conjugate, right? Because of we have a constant divided by a constant plus minus a trig function. So we need to multiply by a Pythagorean conjugate. So this is how it's gonna go. We're gonna multiply this by a Pythagorean conjugate, and it's gonna look like this: 1 divided by 1 minus sine of 1 over 2x multiplied by the Pythagorean conjugate is going to be 1 plus sine of 1 over 2x divided by 1 plus sine of 1 over 2x, and then we're gonna have our dx there, and then that's just it. So this numerator is gonna multiply that numerator, and then this numerator is gonna multiply this this denominator is gonna multiply this denominator, I'm sorry, and then from there we're gonna have this. So we're gonna have 1 plus sine of 1 over 2x divided by 1 minus sine squared of 1 over 2 x, and then dx. And then from there we're going to change 1 minus sine squared into its equivalence when it comes to square identities. Then this is going to be equivalent to 1 plus sine of 1 over 2x divided by cos squared, right? So divided by cos squared of 1 over 2x dx, just like that. And then from there, we're gonna split. So we're gonna make each and every numerator term to have its own denominator. So at the end of the day, what I'm trying to say here is that we're gonna have 1 over cos squared of 1 over 2x dx plus the integral of sine 1 over 2x divided by cos squared. So let me split that cos squared same time into cos of 1 over 2x multiplied by cos of 1 over 2x 1 over 2x and then dx. So why did I split? It's because of I want to make this thing, I want to separate them and then use the reciprocal for this case, and then the other one just say it's it's equivalent. So sine over cos, it's a tan. So that's what I'm trying to say to do. We have discussed this case a couple of times, so I'm hoping that you're not facing any difficulty. And then 1 over cos squared, I'm gonna change it into its equivalence when it comes to reciprocals of trig identities, or trig functions, I mean. So 1 over cos squared is going to be equivalent to what? Sec squared, right? So this is going to be equivalent to sec squared of 1 over 2x dx plus integral of 1 over cos is going to be equivalent to sec of 1 over 2x multiplied by the 1 of cos is going to be equivalent. So sine over cos for this case is going to be 1 over cos multiplied by sine over cos is equivalent to tan, right? So here I'm going to write tan of 1 over 2x dx. So now we analyze our thing. So we can see that something was differentiated for us to get sec squared, right? So before we make conclusions, we need to also make sure that we have the derivative of the argument next to this trig function. So this trig function is has an argument of 1 over 2x. So when we differentiate 1 over 2x, we get what? We get 1 over 2. But then we didn't have this 1 over 2 that I just wrote. So we need to multiply by 2 to cancel it out, right? And then on this other side, the same thing applies. So we're going to put 1 over 2 and then we cancel the 2 out. And then we make some conclusion because of we have the derivative of the argument and this trig function. So we ask ourselves, what is it that was differentiated for us to get positive sec squared of this argument? It was a tan, right? So this is going to be 2 tan of 1 over 2x, and then we come to this. Since we have the derivative of the argument and these two trig functions, what is it that was differentiated for us to get positive sec tan? What is it? It was a sec, right? So this is going to be the 2 that's outside, so it's going to be plus 2 sec of 1 over 2x plus c. Then ta-da, you have your answer to that question that you were trying to do. And then we come to this one. We are not done yet. We come to this. So this is going to be x squared cos squared divided by this is the same question that we did up there, right? Isn't it? Isn't it? Let me just confirm. Cos Oh, it's not the same. It looks similar, but it's not the same. It just looks similar. So it's not the same thing, guys. It's not the same thing. So here we've got x squared times cos squared times cos squared of x cubed minus 2 divided by sine squared of x cubed minus 2. So we can see that cos squared and sine squared, like their degrees are equal. So we can just simplify this by what? By changing this into its equivalence. So cos divided by sine, it's the one of cot, right? So here we're going to get this in simple terms. We're going to get that x squared multiplied by cot squared. So cot squared of x cubed minus 2 the x. So cos over sine, guys, is equivalent to cot. That's basically what I did there. But then when we check our when we remember our thing, there is nothing that was ever differentiated for us to get cot squared, right? So we need to still cook further. So for this case, we are going to make use of our square identities to change this cot squared into cos x squared. So at the end of the day, this is going to look like something like x squared multiplied by, so cot squared is equivalent to cos x squared. Is going to be equivalent to cos x squared of x cubed minus 2 minus 1, and then the x, just like that. And then from there, we are then going to multiply this bracket by this x cubed. So we'll end up having x squared multiplied by cos x squared of x cubed minus 2 the x minus integral of x squared the x. So what did I do here? I multiplied this x squared by this bracket, and then I got what I got there, and then yeah, that's just it. So here, from here, we can then conclude that we know that something was differentiated for us to get cos x squared, right? But then we need to also make sure before we conclude that we have the derivative of the argument. So the argument for this case is x cubed minus 2, right? So when we differentiate x cubed minus 2, what do we get? We get 3x squared. So here we only have x squared. So we need to make sure that we have a 3. And then we cancel out the 3 because we don't want to change the equation. So if we have the derivative of the argument alongside this trig function, then we can then conclude and say that the thing that was differentiated, the trig function that was differentiated for us to get cos x squared, which is positive, was negative cot, right? So it's negative. So this 1 over 3 is gonna go with the that. So this is gonna be negative 1 over 3. So this 1 over 3 is coming from the outside, and this negative is coming from the derivative of what was differentiated for us to get cos x squared, which is negative cot of x cubed minus 2. And then we move to my guy there. That one is simple, guys. So that one is just gonna be x to the power 3 divided by 3 plus c. Ta-da! That's just it for that question. I hope you got it. Another one. We can see that here we're given the integral of 1 minus tan squared of x dx are all divided by sec squared of x. So when we check this thing, we can see that there is no way that there was something that was differentiated for us to get this complicated quotient that we have here. Meaning that we need to do something on this integrand for us to see that, okay, this was the thing that was differentiated for us to get this. So let's simplify this in a way of splitting and making each and every numerator term to have its own denominator. Also I'm doing that because of I can already see that there is no way that I can make one f of x and the other one f prime of x. That thing is gonna fail. So meaning that I can't use general log rule or the general power rule. So I need to think of splitting. So to split, this is how it's gonna go. Guys, one more thing, please be reminded to pause the video there so that you can work out this problem on your own and then resume later to check the memo, of course. So here's how it's gonna go. So this is gonna be 1 over sec squared of x dx minus the integral of 1 over sec squared 1 over sec squared of x multiplied by tan squared of x. So it's multiplied by tan squared of x dx. So we can say that 1 over tan squared is equivalent to cos squared, right? So 1 over tan squared is equivalent to cos squared. So let's substitute that to its equivalence with regards to the reciprocals. So this is going to be the integral of cos squared of x dx minus the integral of cos squared of x multiplied by, so let's change tan squared into its equivalence as well. So we'll change into that one of sine squared of x divided by cos squared of x dx. And then we can see that here cos squared is going to chop cos squared, right? So at the end of the day, we'll just be left with the following: cos squared of x dx minus the integral of sine squared of x dx. So I've already told you prior to the question that we were solving there that whenever we have cos squared, we need to substitute by its equivalence when it comes to half angle identities as well as sine squared. So this means that for the following step, we're going to substitute the equivalence of cos squared with regards to the half angle identities, and that's equivalent to 1 over 2 into 1 plus cos of 2x, and then your dx there minus the integral of 1 over 2. So that one of sine is just is similar to that one of cos, but then the only difference is that this one has a minus sign, and then cos of 2x dx. And then here, from here, we can see that already this 1 over 2 and 1 over 2 will chop each other. So at the end of the day, but then let me just write all the steps to make sure that I avoid mistakes, because I can make mistakes as well. So let me write all the steps. So this is gonna be 1 over 2 integral of cos 2x multiplied by dx minus 1 over 2 integral of 1 dx, and then plus, so it's gonna be plus here because of this minus and this minus here, and then 1 over 2 again, the integral of cos 2x dx. So we can see that this one and this one, they cancel out, right? So we'll just be left with this guy and this guy here and this guy here. So when we add half and half, what do we get? We get positive 1, right? So at the end of the day, I'll be left with the following: 1 integral of cos 2x dx. So now we can say that it's going to be simple for us to integrate this. But first thing first, we need to make sure that next to this trig function, we have the derivative of the argument. The argument here is 2x. So the derivative of 2x is how much? It's just the 2, right? But then we didn't have this 2. So we need to cancel out that 2 by multiplying by 1 over 2. Because if we don't do that, that means we are making our own question from the one that we were given. So now, since we have the derivative of the argument and this trig function, then we can proceed and argue and conclude that what is it that was differentiated for us to get positive cos? We argue and say it is positive sign, right? So this is going to be just 1/2 sine of 2x, sine of that argument, then plus c, then that would be it, and then that would be the correct answer. So I hope you got the same thing as well. Let's quickly check other questions that we can do. All right, so let's see another question quickly. So now we've got this integral. Now we've got the integral of sine x into 1 plus root of cos x squared dx. So when we check here, we can see that there is no way that something was differentiated for us to get this big thing, right? So meaning that we need to simplify this by first multiplying out here, since we have this squared here, by first multiplying out, and then after that we are going to again so we're going to expand this by multiplying out. I'm saying we're going to expand this into two brackets, and then we multiply out, and then after that we multiply by this sign here. So from there, definitely we're gonna be able to do something to this integral. Again, be reminded to pause the video to try this on your own, and then resume later to check the memo. So this is how it's gonna be like for this one. So this is going to be sine of x into 1 plus 2 root of x, 2 root of cos x, 2 root of cos x plus cos x. So what I did there, I expanded this into two brackets. When you expand, you will multiply out. Definitely you will get to this. So don't be confused with regards to what I did there. And then after that, I'm now going to multiply this sine x by each and every term that's inside the brackets there. So I'll end up getting the following. So I'll end up getting that I have just sine of x dx plus 2 into sine x. All right, sine of x. Okay, I'm gonna also change this cos, so I'm gonna write cos of x to the power half. So I changed the root to half, because I can see what we are supposed to do already to this question. And then I multiply again sine with the last term, which is cos there. So this is going to be plus integral plus the integral of sine of x cos of x dx there, just like that. So here we can see that we have the derivative of the argument, which is gonna be 1. So what we need to do is just to ask ourselves, what is it that was differentiated for us to get positive sine x? Then it is that's negative cos, right? So it's negative cos that was differentiated for us to get positive sine, right? So that means our answer here is just gonna be negative cos of x. And then as for this one, the middle integral, we can see that already we need to use general power rule already, because I've written it in a nice way. So because of our n here is not equivalent to -1, so we need to use general power rule. So if we let cos x to be our f of x, then can this be f prime of x? Yes, but then it's gonna be incomplete, because of when we differentiate cos of x, we get negative sine of x. So there should be a negative here, right? And then because of I didn't have this negative that I just wrote here, I need to put another negative outside there. So when I put that negative, it's gonna affect the sign, right? So allow me to just write negative here. Makes sense, right? It should make sense, of course. And then after that, when we have the derivative of this, and this is to the power n, so we are allowed to just use general power rule and say this to the power n plus 1 divided by n plus 1, right? So let's apply our general power rule then. So this is just going to be minus 2 multiplied by cos of x. So cos of x to the power this half plus 1, that's going to be 3 over 2 divided by 3 over 2. So here is gonna be plus. As for this case, this could be done in like 3 ways. One could say I want to make sine x my f of x, and then make this f prime of x, and then use general power rule. Another one could say, okay, I want to use cos x as my f of x, and the other one f prime of x, so then use general power rule. Again, one could say I want to force sine x cos x to be the double angle, meaning that is gonna be 1 over 2 sine 2x, right? And then you integrate that. So all 3 ways could work. So whichever you prefer, I'm just gonna take one for this case, just to make sure we finish, because we have been solving, eh? So I'm gonna make sine here to be my f of x. So it has an exponent of 1 there. So if I make this to be f of x, then this be f prime of x. So I can just use general power rule. That's what I'm trying to say, because I can then say, since this is going to be f prime of x, then this is f of x to the power n, and my n is not equivalent to -1, then I can use general power rule, of course. So that's just going to be sine of x to the power 2 over 2, then plus c. Then one could say I want to simplify further here. You will end up getting minus 4 over 3. So it's up to you. I don't have to do that. I don't have to do that for the sake of time. So yeah, you will do it. You will do it, right? So yeah, anyway, let's continue then. Let's solve the following questions. So now we have definite integrals. So now we are required to evaluate the following questions. As for number 1, being given that the definite integral from 2 to 3 of sine squared of x plus cos squared of x. So we're supposed to integrate this definite integral. So in integration, like I always say, we need to always think of simplifying before we could think of any rule. So if we could simplify, then we have to go with that simplify thing, so that it can make our life easier. As for this case, when we check, we're given sine squared plus cos squared, meaning that for us to be able to simplify this, we can just make use of our square identities, because we know that sine squared plus cos squared is equivalent to 1, meaning that we can rewrite this definite integral with or in the following manner. We can just say 1 and then dx. Makes sense, right? And then we integrate this. So this is going to be x squared. It is just going to be x, man. The integral of this is just going to be x. So this is going to be equivalent to x. We put our limits 3, 2. And then I substitute my limits is going to be 3 minus 2, which is equivalent to just 1. And then tada, you have your answer. And then from there, we can again do another problem. So I hope you got that one, guys. If that one chopped you, hi boo. It cannot do that to you, guys. Please. I hope you got it. That was an easy one. I don't think that one can come in your tests. If it comes, please kill it. All right. Anyway, let's check other questions then. Let's check other questions. So we've got this one, the definite integral from 0 to pi over 2 of sine 5x cos 5x dx, right? So we can force this to be what? To be the double angle, or we can make this or we can make one of these to be f of x and the other one f prime of x. So which one do you prefer? I don't know. Let me just show you maybe both things, guys. Let me show you both methods then, for the sake of I've been avoiding doing this, and maybe you might think that maybe this guy's taking chances now. Okay, now let's start with that one of making one f of x. So I like choosing this one of sine. You will choose that one, of course, to say that will it get to the same thing. So if we make this f of x, then can this be f prime of x? Yes, however, it's gonna be incomplete, so we need to then rewrite this and say sine 5x all to the power 1 multiplied by cos of 5x dx. So when we differentiate sine 5x, we get cos 5x multiplied by 5, right? So meaning that there is a missing 5 here. But then because if I didn't have this 5, I need to put 1 over 5 here, so that 5 and this 5 can chop each other, and then we get back to our question that we were given. So yeah, let me write these limits that were given here. Okay, so now because of I have my f of x and my f prime of x, and my n here is not equivalent to -1, then I can make use of the general power rule. So to do that, I need to just take my f of x and that n, just add 1 to it. So I'm going to continue with this 1 over 5 and then say, what is this? Sine of 5x to the power 2. So I added 1 from that 1 and then divide by a 2. So now put my limits. My limits here is going to be pi over 2 and 0. So this is going to be 1 over 10. So this is going to be 1 over 10. Now I'm substituting my limits. So this is going to be 1 over 10 sine squared of 5 pi over 2 minus 1 over 10 sine squared sine squared of 5 into 0. Then let's see what we're gonna get on our calculator. So I'm gonna punch right now. You can also punch that side to make sure that we get the same thing, but I believe we will get the same thing, right? So I'm punching here pi over 2. So please be patient with me. I'm still on my calculator trying to get the answer. Minus 1 over 10 sine of 0 is 0. I don't have to do this, but I did it. And then I get 0.1. So make sure your calculator is in radians to make sure you get the correct answer. So tada, that's your correct answer. All right, let's quickly check another question. Real quick. I hope you got that one, guys. I hope you got that one. Okay, now we're given that the integral of sine x over 1 plus cos x all inside the bracket squared dx, the limits given that the upper limit being pi over 3, lower limit being 0. So we're required to integrate this. When we check Definitely there is no way something was differentiated for us to get this complicated quotient, right? So what we can do to it is to maybe try to simplify if it's possible in a way that is going to help us. We don't have to factorize if it's not going to help us, right? So we need to check if we factorize, will it help us to integrate this? So if it won't help us, then why do it? We can't be doing such things that don't help us. So yeah, so when we check here, even if we can factorize here, because that's the only way of simplifying, but it can't help us. So we need to think of, can we make one f of x and the other one f prime of x? So when we check, if we make sine x, can this 1 plus this be the derivative of that? No. But then if we make 1 plus cos x f of x, then sine x is going to be the derivative of this, right? And then from there, we're going to make use of general power rule because of our n here is going to be equivalent to -2. So let's rewrite this first in a nice way for y'all to see the thing that is going on. So here's how it's gonna look like when I write it in a nice way. You see, when things are written in a nice way, they also get integrated in a nice way, right? So we agreed that we're gonna make this our f of x. So when we differentiate it, we get 1, and no, we get 0 minus sine x. So meaning that since here we only have sine x, we need to cook it until it becomes the derivative of this. So we need to put a negative sign and another negative sign there because we don't want to change our equation. But then we want to make use of this derivative as well as this function. And then so that we can make use of the general power rule. I forgot my limits there. Pi over 3. Hey, when I write pi over 3. Pi over 3, 0. So now we can make use of the general power rule. So I'm gonna take this negative that's outside should go to the answer, and then we're gonna have 1 plus cos of x to the power -2 plus 1. How much is it? It's just a -1, right? And then divided by -1, and then I put my limits being pi over 3 and 0. Then now I'm going to substitute my limit. So negative and negative will chop each other, and then we'll end up having 1 over this whole thing. And then at the same time, I'm going to substitute my limits. So I'm going to have 1 plus cos pi over 3 minus 1 over, now we put the 0 limit, the lower limit, 1 plus cos what? Cos 0. So now let's see what's going to be our answer. Make sure your calculator is in radians, guys, to make sure we get the same thing. Cos pi over 3 minus 1 divided by 1 plus cos 0. And then, ta-da, we get a 1 over 6. Then, if you don't get 1 over 6, definitely you are wrong. So, ta-da, that's your answer. You should have gotten the same thing as well. So, yeah, let's see if we can calculate this following question. So, here's the following one. Let's see what we can do to it. Let's see what we can do to it. All right, so now we've got this integral. Also, when we check this integral, we can see that there is no way that something, maybe a cos, was differentiated to get this big fraction, you know? So meaning that we need to cook, because there is no way that that thing was, you understand? So we need to cook or rewrite this in a nice way. So let's see. Okay, we can see that there is no way that something was differentiated to get this big fraction. So what else can we do? We check if we can simplify this. So can we simplify this? Can we maybe factorize so that things can cancel out? Those type of things. Can we do that? When we check, yeah, maybe we can for this case, because if we can substitute 1 minus cos squared into that one of sine, you understand what I'm trying to say? If we can change 1 minus cos squared to sine squared, then we're gonna end up. So this could be done in two ways. Okay, we can do this one of, okay, let me just show you, né? let me just solve it in two methods. Okay, let me just solve it. I don't know if I should just explain before solve it, but let me see. Okay, we can just let me just explain before. So there is the method of, if we can simplify, né? By simplifying, we can just substitute 1 minus cos squared into sine squared, and then we'll have square root of sine squared of x squared. Then that's gonna be just sine of x squared. So we'll have cos of x squared divided by sine of x squared, and then from there we will see what to do. Make sense, right? And then another way, one could say I want to use general power rule here. So both ways could work. Both ways could. No. The other one can work. Why did I say two? You see, even me, I'm getting chopped, guys. You. The other one can work, guys. There is no way that we can make this f of x and the other one f prime of x, because I thought that's also gonna work. So yeah, please, I don't know how I got chopped there. I'm sorry. But I didn't get chopped because I understood the first method is gonna work, right? So I was just trying to be fancy there. Coming up with other methods that don't work. So guys, just stick to the same thing. I'm quite sure now you are realizing the pattern. The first thing is to simplify first. If you can simplify, then you need to go with simplifying, because once you try other things, definitely they might not work. You see, now I tried taking chances here, trying to make one f prime, one to be f of x and the other one f prime of x, which was failing for this case. So yeah, please, the first thing is to simplify, because that always works. That always works. You even saw with regards to this one. So hey, please, let's work with the way that work. Okay, so I say that what we're gonna do here is pi, substitute the limits first, and then here on the numerator we'll still have our x cos of x squared divided by what? Divided by the square root of, so 1 minus cos squared is equivalent to sine squared, right? So this is equivalent to sine squared of x squared dx. I shouldn't forget you, my guy. You are the most important thing. Otherwise, without you, what are we doing there? What are we trying to do, man? All right, so square root of sine squared is equivalent to just sine, right? So we're gonna end up having x cos of x squared dx divided by just sine of x squared. Sine of x squared, yes, dx. So here one could say that I want to do what would you want to do there? Let me see what you would want to do. One could say I want to convert cos over sine to cot. That could also work. That could also work. One could just say I want to use general power rule, because I can just say, I can say that from here this is gonna be this sign has as an exponent of 1, and if I make it to be my f of x, then this could be f prime of x. However, it's going to be incomplete because of, we should again differentiate the argument. So here we're supposed to have 2x and then multiply by 1 over 2, and then someone else could just say, so like from here maybe I could use 2 steps, maybe they could reach to the same thing, I'm not sure. So here, since we can make this to be f of x and this other one, the numerator, to be f prime of x, however this should be 2, and then we'll multiply by 1 over 2 to complete the thing. So this is going to be then we're gonna then use a general log rule. So it's gonna be 1 over 2 ln of sine x squared, right? And then we close here, we close sine x squared. We close, and then we put our limits. That's going to be pi over 2. Right, pi over 2, man. What are you writing there? What's wrong with this guy? All right. 1 over 2 ln of sine x squared pi over 2 and then 1 here. Those are the two limits. Another, so someone else could have just said, I want to convert this one to that one of cot, because we have cos, right? So if someone could think of converting this thing to that one of cot, then we will end up having the same thing. Of course, according to the what is this? Okay, what I'm trying to say is this, guys, so that you don't confuse yourself, or I don't confuse you, because I'm the one speaking here and I'm saying you're gonna confuse yourself. How is this making sense? Am I okay? I'm not. So here we had x. So I said one could just convert cos and sine to cot, right? So you will end up having cot of x squared dx. So on your integration formulas, you just need to first cook before you could use the integration formulas, you could just first cook the derivative of x squared to be 2, and then you multiply by 1 over 2, of course. So on your formulas, you'll find that the derivative of the integral of cot is ln of sine. Alternatively, one could have just analyzed it from the get-go and just use general power rule, general log rule, I mean. So these two things will are the same things, because when you use the formulas here, you get this, understand? So it is the same thing. So it's up to you what you really prefer. So I prefer analyzing it by myself sometimes, because sometimes you might forget the formulas, because you are not given the formulas in your tests. So yeah, let's continue. So this is going to be, now we're substituting the limits here. It's going to be 1 over 2. So it's going to be 1 over 2, the natural log of sine pi over 2 squared minus 1 over 2 natural log of sine, what is this? Sine pi over, hey bana, what are you trying to do, man? What are you trying to do? I'm surprised as well. What is this guy trying to do? All right, so now you just need to substitute the thing. Please make sure your calculator is in radians there, so that you can get the correct answer. If not, you're gonna get the incorrect answer, and that's not good, man. You cannot get incorrect answers. You cannot afford to do that. You cannot. Okay, so I'm punching in my calculator, so be patient with me as I punch these things in my calculator. So minus 0.5 natural log of sine 1. Okay. Sine 1. All right. I forgot to square or what. So ln of that. Didn't I change? All right, guys, I'm still punching on my calculator. Please be patient with me. Natural log pi over 2, 0.5. Oh, shit. Just a mistake. The punching mistake on the calculator, yo. This is boring. So here I should have this so that I can square it. So you should get something like negative 0.15. Please make sure you punch correctly in the calculator there, because I had made the mistake one punching on my calculator. I was getting something else and I could say that this is wrong. In no way. So yeah, avoid mistakes, guys, on your calculator. So you should get negative 0.15 like I got there. So let's quickly check another one. We're done with that one. Let's quickly check this guy. Okay, now we have this guy here. What can we do? Since we have sine squared and cos squared, so this could be done like in what way? So maybe in two ways, but they are more like the same thing. So one could just first substitute the equivalence of sine squared with regards to half angle identities directly. Again, substitute this to its equivalence when it comes to half angle identities directly into it there. One could just say this. Okay, so let me write two things. Let me write two things. Let me write the one that I prefer and the one that I don't prefer. But the other one that I don't prefer, I'm just going to write only one step because I don't prefer it. Why? Do things that you don't prefer. Okay, another one could just say sine of x multiplied by cos of x. So here you were, no? Okay. Sine of x multiplied by cos. Why are you writing things? Cos of x squared the x. Another one could have just, okay, before I do that, okay, let me continue with this before I write the other one so that it makes sense what I am referring to. Pi over 4 negative pi over 4. So this is correct, right? I hope you understand maths like I do. So you shouldn't feel like this is incorrect. Okay, so these are just laws of exponents. So makes sense, right? So what I'm trying to do here is to force this to be the double angle, right? I'm trying to force this to be the double angle so that I can just substitute one thing. So this is going to be equivalent to 1 over 2 multiplied by 2 sine of x cos of x to the power of 2 the x. So 1 over 2 and 2 is 1. So this is the same thing as that, right? But then I can make use of 2 sine x cos x. So meaning that at the end of the day, I'm going to have pi negative, bro. Oh, pi is positive up there. And then negative pi over 4 down here. So at the end of the day, I will end up having 1 over 2 sine of 2x, I mean sine of 2x, and then squared dx like this. So that this is what I was trying to do. So what am I trying? Okay, before I write the other way, let me continue with this again so that it could make sense what I'm trying to do. Let me continue again. I will go back to what I was trying to say there. So when we apply the squared thing here, we'll end up having 1 over 4 sine squared of 2x and then dx. Makes sense, right? So from here, we need to substitute sine squared to its equivalence when it comes to half angle identities, right? So I can just first take out the 1 over 4 outside. So I'm going to take out this 1 over 4 outside the integral. So I'll have pi over 4 negative pi over 4. And then I'll have the 1 over 2 into 1 minus. We double this angle. This is going to be cos of 4x. And then dx. That's what half angle identities always mean. So you see what I did there? I ended up substituting only the equivalence of sine squared with regards to half angle identities only. But someone could have just said, from this first step here, I can just say pi over 4 negative pi over 4, and then you substitute the 1 of sine. Same time, you say 1 over 2 1 plus cos of 2x, and then You also substitute the other one, 1 over 2, and then what? 1 minus okay, this one of sine is minus, and the other one of cos is gonna be positive. So cos of 2x, and then you close dx. So one could have just done this from the get-go. However, I didn't want to substitute in two things, so I made did I make it long? I think I did, but I like it. So if you prefer this one, please go with it. We should get to the same answer. We should get to the same, provided that you provided that you didn't make a mistake, of course. So we should get to the same answer, provided that you didn't make a mistake. So please proceed with this if you like it. I like this one. So yeah, we are scattered. What langele but so yeah, I continue when learning Africa. All right. From here, we can see that this 1 over 2 and 1 over 4, they are going to multiply out. So 1 over 2 and 1 over 4, they're going to multiply out. So at the end of the day, we're going to have 1 over 8. So we're going to have 1 over 8 integral of pi over 4 negative pi over 4 into what? Into 1, yeah, minus okay, I don't know if I should split the thing or you guys will understand. Will you understand? But I trust that you will understand. Okay, let me trust you. Should I trust you? Yeah, let me trust you. We have been doing the same thing for quite a long time, so I don't have to split. I wanted to split and have two integrals, but it's the same thing. Poraro potato is the same thing. So now we should integrate this guy. So the integral of 1 is just gonna be this 1 over 8. So this 1 over 8 is gonna multiply everything. So this is gonna be 1 over 8 multiplied by x, because we're integrating with respect to x, minus what? Okay, so this one is going to be minus 1 over 4, of course. 1 over 4 sine of 4x, and then we close the bracket. I put the limits being pi over 4 and negative pi over 4. I hope you are not confused with this 1 over 4. I was scared that I might confuse you because I'm the one writing. So I hope you understand it. Okay, you're saying you understand. So yeah, let's proceed then. Let's then put our limits because we're done integrating. So this is just gonna be 1 over 8. 1 over 8 into, okay, now I must substitute my pi over 4 minus 1 over 4 sine of 4 into pi over 4 into pi over 4. So 4 and 4 will cancel out, of course, so we'll end up having sine pi, and then you close, you say minus 1 over 8, you substitute the same thing again, minus pi over 4 minus 1 over 4 sine 4 multiplied by negative pi over 4, and then you close. You then use your calculator. Please make sure it's in radians. Please make sure it's in radians for you to get the same answer like the one that I'm gonna get. So minus, so I'm busy punching on my calculator right now because I do these problems directly here. So yeah, so sine pi. I don't practice before. What's wrong with me? I should practice my maths. But I'm done practicing. I practiced a lot back then. Oh, so I'm busy punching on my calculator there. Please be patient with me. Negative pi. So I'm getting something like pi over 16. Pi over 16. Pi over 16. So this is what you should have gotten as well, which is approximately equivalent to 0.2. So you should have gotten something like this as well, provided that you didn't make a mistake. Now let's continue and solve the following question. Okay, now we have ourselves the integral of square root of tan squared of x plus 1 dx, the limits being pi over 4 and negative pi over 4 again. They must love this limit, eh? They must love it. Okay, so what can we do here? Definitely there was nothing that was differentiated for us to get this square root of what, right? So meaning that we need to do something to this equation until we have something that was differentiated, you understand? So to do that, we need to think of simplifying first, which is the first thing that we think of in integration. So can we simplify this in a way that is going to work for us? You can't just say I can factorize, but then it's not working for you. Then what were you doing? Okay, so yeah, when we check, we've got tan squared of x plus 1, which is one of the square identities. So we need to just substitute tan squared of x plus 1 to its equivalence when it comes to the square identities. So it's equivalent to sec squared, right? So this is going to be pi over 4 negative pi over 4 negative pi over 4 multiplied by square root of this is going to be sec squared. So this is going to be equivalent to sec squared. So let me put it in a square root. So it is equivalent to sec squared of x, right? I should not forget my dx. So square root and squared, they are going to chop each other. We'll be left with pi over 4 negative pi over 4 sec of x dx. And then the integral of sec x is what? The integral of sec x, if you could go to your formulas, your integral formulas, you will realize that the integral of sec x is just a ln of sec of x plus tan of x dx. Oh no, what is dx doing? What is he trying to do now? You see this guy now, it's 210 now. This 210 now. Okay, pi over 4. So I've substituted my limits there. So now, I didn't substitute, but I'm about to substitute them now. So what you had to do then, okay, so I proceeded with the integral formula because of, I could say that already the derivative of the argument, it's 1 here. So you can't proceed with the formulas before you have the derivative of the argument there here. So yeah, now let's substitute our limits. This is going to be the natural log of sec pi over 4 plus tan pi over 4. All right, minus what? Minus the natural log of sec. Right, sec, me, bro. Sec negative pi over 4 plus tan negative pi over 4. Then you close, of course, you're gonna close here. All right, then you use your calculator. So where there is sec, you can just substitute by 1 over cos in your calculator there. Where there is sec, you can just substitute 1 over cos. So for you to get the answer. Another thing, make sure your calculator is in radians, because we're dealing with radians here. It's not degrees. For you to get the same answer, plus tan shift pi over 4. So I'm busy punching on my calculator as well. So be patient with me. Be patient with the tutor. Yeah, be patient with the tutor. Minus pi, minus pi over 4 plus tan into negative pi over 4, you close 2 times. Okay, it's cooking. So I'm getting something like 1,763. Then you should get the same thing because I don't make mistakes, guys. So you should get the same thing. So yeah, but I hope you are getting the content, guys. I hope you are getting the content. There is nothing tricky. You're also getting the writing format in your test. This is how things should be written in your test, and they should be correct, just like mine. Okay. Yeah, we've got another question. This one we've discussed it a lot. I'm quite sure even you right now you can solve it in your dreams, right? This type of one. Whenever we have a constant divided by a constant plus minus a trig function, we do what? We multiply by a 1. But that 1 should be a Pythagorean conjugate. A Pythagorean conjugate. So here's how this one is gonna go. So this is gonna be pi over 4, 0, 1 divided by 1 plus cos 30 dt, right? Oh, I should remove this dt. Let me write it far enough. And then now we should multiply by our Pythagorean conjugate because we have a constant divided by a constant plus minus. It's that format. So we multiply by a Pythagorean conjugate. So it's going to be 1 minus. So remember to oppose the sign, guys. Remember to oppose the sign. So it's going to be 1 minus cos 3t, where I given 3t there, divided by 1 minus cos of 3t. And then from there, we multiply the numerator by the numerator and also the denominator by the denominator. So we'll end up having the following: pi over 4, 0. So this is going to be 1 minus cos of 3t divided by 1 minus cos squared of 3t dt, just like that. And then from there, we need to simplify, right? We need to just substitute. 1 minus cos squared is going to be sine squared. 1 minus sine squared is going to be 1 minus cos squared is going to be sine squared. That's what I'm trying to say. Why am I saying things that are not make sure? Pi over 4, 0. So we're gonna have 1 minus cos 3t on our numerator. There is nothing that we have done to it yet. So this is equivalent to sine squared of 3t dt. Then we split from here. We're going to make each and every numerator term to have its own denominator. The procedure for this type, guys, is always the same. It's always the same. So I'm quite sure now you have crammed it, right? If not, please cram it now. It's not late yet. Please cram it. Please cram this format or this procedure. Okay, so I'm splitting so that each and every numerator term has its own denominator. All right. So this is going to be pi over 4, 0. We're going to have 1 over sine 3t and then cos 3t divided by sine of 3t dt. So now what did I do here? So instead of having sine squared here, I splitted the sine squared into sine multiplied by sine, which is still sine squared. And then so that I can have 1 over sine cos over sine, right? So that it can work in my favor. Wow. Okay. So 1 over sine squared is equivalent to what when it comes to the reciprocal identities? It's equivalent to what? That's what I'm trying to ask you. So it's cosec, right? So this is cosec. So this is cosec squared, because of we had squared there. Cosec squared of 3t dt minus the integral pi over 4 0 1 over sine. How much is it when it comes to the reciprocal? So that this is a cosec as well, right? So it's a cosec of 3t. So this is going to be cosec of 3t multiplied by cot. So cos over sine, it's a cot, right? It's cot of 3t dt. So now we need to integrate. But before we could integrate, we need to make sure that next to this trig function, we have the derivative of the argument. The argument, I said, is an angle, so don't be confused by the word argument. So the derivative of 3t, how much is it? It's gonna be a 3, right? So we should make sure that we have a 3 here before we could integrate, and then we cancel out this 3 by multiplying by 1 over 3. And then the same here, we should make sure that we have a 3 and then 1 over 3. Then we can see that something was differentiated for us to get cosec squared, and as well as this side, something was differentiated for us to get cosec cot. So let's start with this guy here. So because of we have the derivative of the argument and this trig function, we then ask ourselves, what is it that was differentiated for us to get cosec squared, which is positive cosec squared? What is it that was differentiated for us to get positive cosec squared? What is it? It's negative. So negative 1 over 3. The 1 over 3 should go to the answer as well. Negative 1 over 3 cot, right? So it's going to be negative 1 over 3 cot of 3t, just like that. And then I shouldn't forget the limits being pi over 4 and 0, and then I say minus these other ones, because I have the derivative of the argument and these two trig functions. So, and I know that something was differentiated to get cosec and cot, right? So I just ask myself, what is it that was differentiated for me to get cosec cot? What is it? It's negative cosec, right? So it's going to be negative cosec. So, all right. So this negative that I wrote outside here comes from there, right? It's coming from there. You understand? So when I integrate this, I find that there is another negative that comes from when I ask myself what is it that was differentiated to get positive cosec cot. You understand? So it's negative, so that which end up making this sign to be positive, this sign here. You understand? So I'll end up using 1 over 3 cosec CSC. So CSC of 3t. I put my limits being pi over 4 and 0. So because of these limits are the same, guys, so I can just remove this one to avoid having long things. So it's allowed to do this. And just have one thing there. You understand? You do understand. So since you understand, let's just substitute our thing in the calculator then. So let me rewrite this first. So let's substitute. So because of we can't put your cot there in the calculator, we can just do this. So we can just convert cot into tan, right? So it's going to be 1 over tan. So this is going to be minus 1 over 3 multiplied by 1 over tan of 3. I substitute my limits being pi over 4 plus 1 over 3 cosec. It's that one of sine, right? Is that one of sine. So this is going to be 1 over sine as well, multiplied by 1 over sine 3 multiplied by So it's going to be 3 multiplied by pi over 4. 3 multiplied by pi over 4, of course, minus, you substitute the other things. So this is going to be minus what? So we substitute the limits there. Again, the lower limit, I mean. So this is going to be minus 1 over 3. Minus 1 over 3, 1 over tan of 0. So yet, please don't be confused by 1 over tan, guys. 1 over tan is equivalent to chord in terms of reciprocals. I am doing this thing because of you cannot be able to substitute chord into your calculator there if we are using the same calculator, but then you could be using another calculator there. So if you are using a professional calculator, or I don't know which one that is that you may be using, please use it. Then if you can substitute chord there, please do it. Mine, yeah, I can't be able to do it, so that's why I converted this into the things that I have right now. Multiplied by 1 over sine, right? Sine of 0. Okay, now I'm going to substitute everything here. So okay, tan 0 is 0, sine 0 is 0, so we don't have to substitute this part. We only can focus on our this side only. We can just focus on this side only. So I'm punching now in my calculator. Please be patient with me. Tan 3 multiplied by pi over 4. Here you are now. Plus 1 over 3 sine 3 pi over 4. Yeah, you should get something like 0,805. Then ta-da, that's your correct answer. That should be your correct answer. So yeah, that's just it. That's just it for that one. Let's see what we can do to this one. Okay, I hope you got that one as well. So now we've got the integral of sine of ln of x or upon x dx. So this one is simple as well. We are almost done with it already. So we can see that this one is already clear. We already have the derivative of the argument and we have the trig function. I can just rewrite it in a nice way so that you all don't get confused. So I can just say 1 over x multiplied by sine of ln of x, then dx. So because of I have a trig function and the derivative of its argument, then I can just ask myself, what is it that was differentiated for me to get positive sine? What is it? It's negative cos, right? So negative cos was differentiated for me to get positive sine. So therefore the answer for this is just negative cos of ln of x, right? And then you put your limits there being e and 1, then you substitute them. So this is going to be negative cos of ln of e, right? Ln of e minus into cos of ln of 1 is 0. Okay, this is going to be ln of 1. Then you close. Then we get our answer. So let's substitute now. Let's substitute. Make sure your calculator is still in radians. Make sure that your calculator is still in radians. So ln of e, I close, minus into, I forgot a negative sign here. Sorry, I forgot a negative sign here. Sorry, I forgot. I'm seeing now when I'm substituting that, what am I trying to do? Cos of ln, So I'm busy start punching in my calculator. Please be there with me, please. So 0,46. 0,46 should be your correct answer. So yeah, you should have gotten the same thing, provided that you didn't make a mistake, of course. So yeah, that's just it. That's just it. Let's quickly check if we can solve another one quickly. So now we have this one. Okay, this one maybe it could trick you because of we haven't done inverses, but it's the same thing, guys. It's the same thing. The procedure is the same. So look, guys, here we can see that we cannot be able to make, we can see that there was nothing that was differentiated for us to get this fraction, right? So we need to simplify it in a way that we could see that, okay, this was differentiated for us to get this, you understand? So we need to rewrite it nicely. So simplifying is not working. We cannot substitute anything here. We cannot substitute something or factorize in a way that it could work for us, like maybe things cancelling out and then this integral somewhere somehow end up being simple, you understand? So we then need to think of, can we make one f of x and the other one f prime of x? It fails as well. If we make this f of x, that can't be the derivative of this, right? So even if we can make this f of x, this can't be the derivative of it. So we need to again think of something else. So when we check this format, this is the format. It's more like, look at what I'm gonna write here. We have this format here. I don't know. What is this equivalent to, guys? Just 2 seconds of your time. Do you remember this type of shape? What is it for? Yes, it's the one for tan, right? Tan inverse. So this is tan inverse that was differentiated for us to get this thing. So if we can make, we can rewrite this in a nice way so that we all can say that it is really that thing, guys. So unfortunately, yes, we haven't discussed inverses, but yeah, we have done differentiation. So it's the same thing, guys. It is the same thing. So sine of x and then squared dx and then pi over 4 0. So we can see that this thing, it's in this format, right? It's in this format, right? So we can see if we let sine x to be f of x, then cos of x can be f prime of x, right? Because of when we differentiate sine x, this becomes cos of x. So we can just say, we can then just conclude that then tan inverse of sine x was differentiated for us to get this integral, you understand? So we just put the limit here, pi over 4 0. Then we substitute our limits. It's going to be tan inverse of sine pi over 4 minus tan inverse of sine of 0. Then from there, we are going to substitute this in your calculator. I hope you know how to punch inverses, guys, in your calculator. You do, right? So you can just say shift, you press tan. Shift tan is going to be simple like that. Shift tan, you'll see that it will be tan inverse. And then you punch everything. Make sure that, again, it's in radians. And then from there, it's going to be simple. Minus shift tan inverse of sine 0. you should get something like 0.615. Then tada, that's your final answer. So yeah, that's it, guys. That's just it. So we're done with that one. Let's quickly check if we can solve this other one, so that we can close this. We've been solving for quite some time now. We can close this. Okay, guys, remember to pause the video so that you can work out this problem on your own and then resume later to check the memo. So now we've got 2 cos squared of 4x dx. So we need to integrate this. To integrate this, what are we going to then use? So we can see that if we, so since we have cos squared, whenever we have cos squared, guys, we just substitute it into its equivalence when it comes to half angle identity. So the first thing that we can do here, we didn't have to think much here. So is to take the 2 out. So when I take the 2 out, 0 will be left with cos squared. Cos squared, I substitute it into its equivalence. This is going to be 1 plus, I double the angle, there is going to be cos of 8x. And then I close, I have my dx. I can take the 1/2 out, and then it will cancel out with the 2. So at the end of the day here, I'll be left with just the integral of pi over 4, 0, 1, and then dx plus the integral of pi over 4 cos of 8x dx. Makes sense, right? So because I have this, then I then conclude and say that the integral of 1 dx, or that one is simple, right? Even me, I can be able to do it. Imagine, okay, pi over 4, 0, then plus, now you integrate cos of 8x. Remember, before we integrate, we should make sure that we have the integral, we have the derivative of the argument, which is going to be 8 for this case, and then 1/8 here. So then we ask ourselves, what is it that was differentiated for us to get positive cos, right? So what is it that was differentiated to get that? It is positive sign, right? So it's gonna be the 1/8 here is gonna go with it. So it's gonna be 1/8 sine of 8x, and then we'll put our limits there. It's just gonna be pi over 4. And why did I write a 4 here? Am I crazy? Yeah, I am. So here, since we have the same limits, we can just use one limit, guys. So let's remove this. Remove when I remove you. So we can just remove it and just have one thing. Then from here we substitute. So this is going to be pi over 4 plus 1/8 sine 8 multiplied by pi over 4 minus into 0 plus 1/8 multiplied by sine of 8 into 0. Then you close, then you substitute. So everything here is going to be 0 because sine 0 is 0. So when you punch this on your calculator, you should get something like pi over 4 plus 1/8 sine of 2 pi, which is just gonna be just your pi over 4. So you should get something like pi over 4 here. And then ta-da. Yeah, that's just it, guys. That's just it. Let's see if we could solve something else, right? Remember to pause the video before before you check the meme, so that you can say, are you getting the concept, are we getting the same things? So that's the thing. So that's how to learn. That's how to learn. I also learn like that when I'm learning things. So maybe it could work for you as well, so please try it. Otherwise, okay, what am I doing now? Because I'm just writing without explaining. Now erase everything and explain, Baba. You can't write without explaining. So here we've got 1 over 2 cot squared to theta d theta. So when we check this, there is nothing that was ever differentiated for us to get cot squared, right? So we need to do something to this question until we have something that was differentiated to get that thing that would have written, you understand? So what is cot squared equivalent to when it comes to whatever identities, reciprocals, the one that works? So we know that according to the square identities, cot squared is equivalent to what? So cot squared is equivalent to cos x squared minus 1. Cos x squared minus 1. So here I can just say integral of pi over 3 pi over 6, and then I substitute this one here. So cot squared, I've already told you that is equivalent to cos x squared minus 1, right? So this is with respect to theta minus 1 d theta. So here already, or I can take the what, the 1 over 2 out there. So I can take the 1 over 2 out, or maybe I should have taken it out here already. It's fine, it's the same thing. And then what? From there, I need to integrate, because now I can say that something was differentiated to get cos x squared, right? So let me do this. Let me rewrite it again in a nice way so that we avoid mistakes. So let me write cos x squared of 2 theta d theta here, minus, I can just put again the 1 over 2 cos is going with everything, integral of 1 d theta. Okay, I forgot the limits here. Pi over 3 pi over 3 pi over 6. So what's happening here? The thing that's happening here is that now I can see that I have a trig function here, and I know that I should make sure, before I could integrate, I should make sure that I have the derivative of the argument next to this trig function. So the derivative of 2 theta is what? It's just a 2, but I didn't have this 2. I should multiply by a 2 here, you understand? So I should multiply by 1 over 2. What's wrong with me? Since I wrote a 2 here, I should multiply by 1 over 2 here. Makes sense, right? The 1 over 2 that's outside already is that one. So this one is this one. Makes sense, right? This 1 over 2 is this one. And then this one is for cancelling this 2. I hope you are not confused. So outside there, I'll have 1 over 4. So now I can just ask myself, since I have the derivative of the argument and this trig function, I can just ask myself, what is it that was differentiated for me to get cos x squared? What is it that was differentiated for me to get cos x squared? What is it? It's negative what? So it's, since it's positive, that one, then the one that was differentiated for me to get cos x squared has to be negative cot, right? So it's gonna be this 1 over 4 from from the outside. So it's going to be this 1 over 4, negative 1 over 4 cot of 2 theta there, and then I can just put my limits, put the limits here. So it's gonna be pi over 3 pi over 6 minus the derivative of 1, the integral of 1, guys, that one, guys, boo, hi boo. So yeah, it's just gonna be theta for that one because we're integrating with respect to theta. So since I have the same limits here, I can just use only one. So let me just remove this. Let me just remove this, and then yeah, then this is how it's gonna be like. So now I need to substitute the limits into this thing to get my answer. So we know that cot, we can't punch it in the calculator if you're using the same calculator as me. So let's then convert that cot into the reciprocal to 1 over tan 2 multiplied by pi over 3 minus 1 over 2 multiplied by pi over 3 minus into minus 1 over 4 1 over tan 2 multiplied by pi over 6 minus again 1 over 2 multiplied by pi over 6, and then we punch in our calculator. We should get something like what I'm about to get here. Otherwise, if you don't get the same thing, it's wrong. Okay, so I'm busy punching on my calculator right now, so just be patient with me. I'll be done just now. So 2 pi over 3 minus 1 over 2 into pi over 3 minus, or I can just say plus 1 over 4 tan 2 pi over 6 plus again 1 over 2 multiplied by pi over 6. So you should get something like 0, 0, 2, 0, 0,0269. So we should get the same thing here. So that should be your answer. You should have gotten the same thing as well. So I converted cot into tan, like I told you that. Now I'm telling you again. What's wrong with me? So now we have this. Okay, now we have got the integral of sec cube of x plus e to the power sine x dx. So definitely there is no way that they differentiated maybe a cos or a sine to get this big fraction, right? So we need to simplify this or try to think of another way. So let's start with simplifying before we could think of something else. The first thing is to simplify. So to simplify this, what do you think we can do? We can just split it, right? Because I can see if we split it, then we're gonna have sec cube divided by sec, and then 1 over sec multiplied by that, which looks like it can be integrated, of course, definitely. So yeah, let's go with it. 1, 0. So this is going to be sec cube of x divided by sec of x, and then I can just say dx plus the integral 1 over sec of x multiplied by e to the power sine of x dx. So this is going to be sec squared, right? So 1, 0 is going to be equivalent to sec squared of x dx plus the integral of this 1, 0. So 1 over sec is equivalent to cos, right? So this is cos of x e to the power sine of x dx, right? So we can see that what is this? The integral of sec squared, what is it equivalent to? Okay, before that, we need to first make sure that we have the derivative of the argument. The derivative of the argument here. So the derivative of x is 1. So we do have 1 here. So we ask ourselves, what is it that was differentiated for us to get sec squared? It's a tan, right? So we have tan of x. And then we come to this one. So here we can see that we're integrating an exponential function. To differentiate an exponential function of e, the base being e, then we just need to make sure that we have the exponential function and the derivative of the exponent. So the derivative of sine x is cos x, so meaning that this is already in a nice way, right? It's already in a nice way. So it's going to be just that exponential function, because of we have the derivative of the exponent. So the derivative of sine x is just cos x. So this is just going to be plus e to the power sine of x, and then we put our limits being 1 and 0. Then we can substitute the limits from there. So this is going to be tan of 1 plus e to the power sine of 1 minus tan of 1 plus e. Now I'm substituting 1, supposed to be 0, the sine of 0 again, and then we use our calculator. We should get something like what I'm about to get here. So this is going to be 1 plus e to the power sine 1. So make sure your calculator is in radians. I'm busy punching right now. Minus tan of 0 plus e to the power 0. Okay, then we close tan 1. Okay, sine 1, 0, 0. You should get something like 2,872, and then that should be your final answer. So that was it for this tutorial. I hope you got it. I'll see you in the next activity. Take care, or in the next video.